All right. Can you guys hear me now? You guys hear me through the lapel? All right, here. I went and got that out of the way. Much less nicer versus having a giant microphone in your face the entire time. So, all right. What we're going to be doing here, so this is a customer's machine here that I have. We're doing quite a bit of upgrades to it. We've got the dual board here. We got the stepper motor and wire. What do you do with this tough extruder for your ender? Look up any sort of Titan extruder assembly. It goes together just like the Titan. And I'm going to be putting two of those on here today. So we have not done a video on it yet. It's very much a DIY product. So anyways, I've got all the parts here. I got my dual Hotend, two Titan clones here that we sell. We call them the tough extruders. And then the CR-10S dual board with the motor. And then we've got all the printed parts here. So we're going to be doing the PETS Fang. I've got all the parts printed in ABS plastic already. We got our ducting. We've got our mount for the actual hot end. And then we've got the two brackets here. And then I've also got a sensor mount because he's got the Easy ABL. So this will all go together. I got all my parts pre-printed. The PETS Fang is the recommended one. Morwick, send an email to support@th3dstudio.com and we'll send you some links. So I'm going to start here by taking the actual e-motor cable out. So this is a whole assembly that we get from Creality. So you got two stepper motor cables here. The one's labeled X, one's labeled E. We're going to grab the one for E, and they're all labeled here. So I'm going to take these out of the tubing just by pulling this and then pulling them through the end here, because we do not need all these cables. We just include them because it costs us the same amount to get this one that comes with the extra end stop cable and the X. So might as well send you guys some extra cables if you ever need them. So I'm going to go here. I got my E. And then we're going to go ahead and set this off to the side. So this is going to be the cable that we're going to start with in terms of routing that. And then we've got our dual hot end here and all the other parts. So this is just a customer's ticket of the bill of work to be done. So I'm going to start by swapping the board here. So I've got my control box here and it's still connected to the machine. So I'm going to disconnect this. The PETS Fang puts out a lot more air than the regular Fang. And the regular Fang, especially if you use the one with the probe mount, it tends to wobble. So it's not very good. I'm just disconnecting all the switches here so I can free this machine from the control box. It looks like this guy's got the Easy Connect and he put his own little wire harness together, or power connector on here. So I'm going to go ahead and disconnect the Easy Connect here. And then get this going here. Parts are printed in ABS because ABS withstands the heat more, and anything you have near your hot end, you're going to want to have an ABS, especially with the PETS Fang where the ducts are right by the heater block. They will sag and they're going to basically hit as they warp. So, and he's got dual Z on here, so I got to disconnect this motor too. All right. So, if I can get these, he really tightened these screws down. He did not take the thumb screws as thumb screws. It feels like he actually tightened them down. So I'm gonna have to actually use a screwdriver to get them off. Power the thing off and put the card in and power on. I'm not sure what you mean there. Oh, you're talking to another guy in the chat. So, yeah, I'm looking at the volume levels right now. If anything, it might even be a little too high. So I'm going to set all his stuff off to the side, and we're going to start by taking apart the control box here. So let me get our little close-up cam in the works here. Let me switch over here to small cam, and this will give you guys a nice shot of the thing here. Let me see. I need to move this down in the order. There we go. All right. So now we got our view back. I was messing around with recording in OBS, so that's why it was all weird and wonky and not showing you guys everything. So how's everybody doing today? This is my day off. I actually haven't been online much today, and I figured I got to do this job anyways. I might as well stream it because we have one for the 2-into-1, and we've also got one for the we got one for the 2-into-1 already, and not one for the dual Hotend. So I figured let's do the dual Hotend. So I am using a 2.0 hex to take these out, in case anybody's wondering. I got my little screw dish here, which we're going to put all the customer screws in so I don't lose them. I did just hear something fall into the enclosure. Is this, you guys can hear me okay, right? It's not breaking up or anything. I do have my wireless receiver for the what's the word I'm looking for? For the mic pack on an extender. Let's see. Is the Creality still a recommended printer for under $500? I don't think so. If you don't need the build volume, the G-Tech A10 is a really good option. Just a fair warning, I'm done with Creality. I don't know if you guys saw, but Printed Solid stopped selling them because basically they're not complying with the GPL anymore. So I won't be buying any more machines from them. I will be putting out aftermarket parts for them still, just because I know there's a lot of people that are going to need things to be fixed, and it'd be stupid business-wise, but I'm not going to recommend people purchase the machines anymore because they're not playing ball. And there's more details, but there's another video coming on that. So the TiVo Tornado is a good machine. They made a lot of improvements since the first version, so I could recommend that one. The only thing is they still might be shipping with kind of crappy power supplies, so fair warning on that. It looks like this guy has already been in this machine here. Maybe he replaced his fan and mounted it with some sort of vibration dampeners. The A10 is nice. I don't know if you guys see that benchy sitting there in the background, but that thing was printed off the U10. I did get a layer shift because the nozzle hit something. What it hit, I'm not sure, but it definitely hit something. Oh, this guy's got some mods in here already. He's got upgraded fans. I don't know if these aren't ours, but he put them on vibration dampeners, and he's got a Noctua in the rear, so he's already done some upgrades on this machine, as you can tell. I'm going to take this power supply completely out, just so I don't have to be fighting with the wires this entire time. So if you guys are working on these, I would recommend taking the disconnect the stock PSU. And for the AC side, neutral is the black coming from the AC outlet, and red is your line. And do not mix those up and accidentally put them onto the DC side when you reconnect everything. So I'm just loosening up the screw terminals here. I have not tried the U20 yet, but I do have one on the way. GearBest has one, and I got a shipping notification, so I'll be checking that one out. I'm curious to see what kind of firmware they're running on it. I'm really hoping that they aren't doing a GPL thing, but they are sharing the firmware for the U10. It came on the SD card, actually, so that was good to see. I'm just looking at his MOSFET, make sure there's no burn marks on it, because some of them have them. His looks okay, so we don't need to replace that while we're in here. This is a little janky here. His pins are just kind of coming out of the sockets here. It looks like he used the wrong type of pins on here. I'll have to make sure that that works correctly. So basically, we're just swapping the entire control board. He's already got a CR-10S board in here, so this should go fairly quickly. Let me hear. I'm going to move my chat over to my other screen so I can see you guys better. Yeah, so we're going to be swapping this out. He does not have the second E-motor driver. You can see it's missing there, which is why we have the dual board. I do Bowden on most of my machines, but you can play around and see what works for you. So I'm just taking these out of here. Taking the screws out. I am going to grab this though, just because I don't want to risk shorting anything out. And just ground myself to the chassis. Where can I grab on here? I'll grab. There we go. Alright, just disconnecting our limit switches. And getting to the last few screws. And this board actually looks, I don't know if this is one that he got from like Tiny Machines or something that already did the cap fix, but his board has the actual aftermarket cap fix, not the Creality one. How if I had though, if I could get my hands on the screws. Alright, so we're going to disconnect all the cables here. We got brown is our hot end, and red is the bed temp. And his controlled fan is got a blue mark on it. I think he marked all these, because I think this board was sent in for repair at one point. Because it's either got a fix from myself or a fix from Tiny Machines. I probably could check his stuff in here. His fans are wired onto the main power input here. He's got, these were just hanging in there. This literally just pulled right out. Not good. I'll have to make sure we secure those correctly when we put it back together. There are other options. TH3D has the tough tubing, which is another high temp tubing that's on the market, and it's cheaper too, especially if you're getting more than 1 meter. So silicone socks are great. I highly recommend them. And I'm just undoing our hot end connections here, and then our bed, and then our main power. Let's see. Will the EasyABL sensor work on a RAMPS 1.4 board? Yeah, it works. It'll just work like a regular end stop switch. That's what it shows up as. So, alright, we got our power wires here for the board. Now, here's the thing. This is, if you guys notice, these wires are tinned. These should never be tinned because these go into screw terminals. So we're going to have to cut these and solder them, because, or cut these and strip them, because these should not be soldered. These are going to create hot points in the actual, what's the word I'm looking for? In the terminal. And I don't know why these Chinese companies keep soldering them, but it's actually a fire hazard. Mac, I'm going to add you as a moderator. So there we go. All right. Good old built-in teeth strippers. I'm going to say don't recommend you don't do that, but I don't know where my wire strippers are. They're probably packed up and I don't feel like getting up. So, all right, we got the old board out. We got to remember to hook up his always-on fans again, which are these random wire leads that are sticking out here. Now, when you add the second hot end on, luckily he supplied me with some quick disconnect connectors, so we are going to put the extra thermistor and the extra heater wires onto there, so he can still disconnect it completely from the machine. I'm just moving these wires around because the bed wires are the same color as the always-on fan wires. So what we should do here, so here's always-on fan wires. Actually, this is for his probe. Now I look at it, this is for his ABL probe. This is one fan, and you got your control box fan back here, which has got that wonky connector on it. And where's his other one? He's got one other fan that's going to be on all the time. Okay, that's this guy here, which has a plug on it. So what I'm going to do is, because I don't want this guy accidentally having a short, I'm going to go ahead and we're going to clip these and splice these all together and then solder them, because this is unacceptable. Like, look, I can just pull the pins out. Not quite sure what he was doing there. It looks like he took the 3-pin parts out and then just wedged them in there and hoped for the best. So I just took the sleeving off because we're going to get rid of this. Anytime you got 3-pin fans and you have the yellow wire, this is for RPM sense, which your printer does not need. So this can just be done away with. Doesn't need to do anything. It can just not be connected. So I really wish I knew where my wire strippers are, because I don't want to be stripping all these with my freaking teeth. Alright, let me see if I can find my wire strippers. Ahaha. Got them. This will make life a lot easier. Alright. So yeah, I'm just gonna, these are the always on 12 volt connections. So we're gonna go ahead and just strip these here. These are awesome. If you guys haven't used these type of strippers, they're freaking great. They cut the time down significantly. Just put it in there, boom, stripped wire. They're awesome. Whoa! I'm going to drop stuff. I'm going to knock things over, as I just did there. It's just part of the channel. Alright, so these need to go to an always on 12 volt. So what I'm going to do is just tie these all together, because we got our rear fan, the EasyABL power wire that he ran, which we're going to retain that. And I'm going to just twist these together here. And then we're going to tin those with solder. And I'm going to put a leg off of them to go to... Actually, I might be able to put these right off the power supply if I crimp an end on. I may just do that. But these need to be on all the time. It looks like I got enough cable to go to the power supply. So if I locate my crimps, I should be able to do that. Question are, what bin are they in? Because my guys use stuff like that during the day, and I have no idea where it goes half the time. And there's stuff in front of the closet here. Yeah, we're not moving all that on stream. Screw it. All right, well, we'll wire these up to a 2-pin plug to go to the main board on the VIN plugs. So I should have something in here. Let me turn my Hotco on. And I'm actually trying to think of how to do this here, where I want to pull the 12 volt power from. Let me see if I got any 2-pins in here. 2-pin JSTs. Alright. Just order the Easy Connect. We include an adapter that does just what you're wanting to. They're included. I just have not updated the product description yet. It is mentioned in the manual though. Trying to see if I got any 2-pin JSTs in here. I got plenty of 3-pins. Don't know if I got any 2-pins handy though, because this needs a female 2-pin JST. This is like my bag of random wires and cutoffs, and usually stuff like that, just like a little pigtail I cut off a fan or something from one project, will usually end up in here. I've only got 2 pins in here, so that's unfortunate. Or I've only got 3 pins, I should say, no 2 pins. And I don't think I have any in this drawer. I do not. All right, so we'll have to go ahead and crimp those later. All right, so let's get our new board installed here. Now, when we're wiring up the hot end, I want to see if we got enough length to go all the way for the second heater. The first heater we can splice into the existing wires and retain that. But there's 3 heater cartridges in the Tough Dual hot end, which is what we're using here. This is the one we sell. And there's 3 heater cartridges. There's one for the mixing block, which I don't think really anybody's using that. But it's got a slightly longer heater cartridge than the others. So you can see these 2 here, and this guy's a little longer. So this is for the mixing block. It's just a longer heater. And then we've got our we got our 2 regular ones. So just looking at this here, should have about 1 meter on these. Yeah. So what I'm going to do is, because I don't need all of the length of the 1 heater cartridge, and we're going to need to put quick disconnects on there anyways, I'm going to cut the wire on this one in half, and then we'll use the excess wire from this 1 heater for the other one. So that way we don't have to use any additional wires. And then we'll put a disconnect connector on the end here. And same thing with the thermistor wire. So I'm going to go ahead and get this wire run into the enclosure so we can then use it. Let's see. Is it Easy Mat grainy like painter's tape? I'd say it's slightly less grainy. It's not like glass. These wire strippers do not like these sleeved wires. Usually takes a couple tries. There we go. And then I gotta trim back the excess here. All right. So you're left with like this little frayed end. What I usually do is I separate the wire from it, and then I just take my side cutters and snip the excess cover, the actual wire cover, off of it. This is like a cloth sheathing on it. It helps with strain relief and whatnot. So now we got a nice wire to put in our terminal. So I'm going to feed that one through the back here. I'm just going to put out the wire grommet with the other wires. I'm going to do the same for the other wire I snipped here. I wish there were extra pins on the existing port on the back here, but there's not, so we gotta kind of DIY it. And I'm just tightening up the nut on this one jack because it was loose, and I don't want to have that loose. Might as well, I kind of go over everything when I'm working on a machine, just to make sure everything's in order. All right, so we're gonna take our new dual board here. Mirror, you need to have adhesive on it. Otherwise, you're not going to have a good time. So we got our new dual board here. You can see Here's the E1 plug, and here's the E1 driver. It's actually populated on these boards. This is the main difference of this board versus your standard CR10 board. So if you look at them side by side, you can see the difference here. This chip, okay, this chip is not right here. You can see it is here on our board. So that's why people are paying the money for the dual board, is this actually has the driver chip installed. Your stock one does not have the driver chip installed. So it's essentially the same board, it just actually has all the parts on it. And unless you have a way to reflow and do surface mount soldering on a package like that, you're not going to be able to get that on there. I know some people have been successful with it, but it's a pain and you usually end up damaging your board anyways, so it's not really worth it. And this board goes in just like the original board, just line up the screw holes, and then we'll tighten everything down. Alright. Might help if I have my screwdriver here. And our bit. Yeah, I don't use the, of course I dropped the screw in. I don't use the glass anymore. We 100% use the Easy Mats because I got tired of putting hairspray. Yeah, the mats just stick down. They're so much less work. That's why I switched over to them. Alright, so new board's in, SD and the USB are lined up, so I'm going to tighten down one of the screws here. And then we'll get the other 3 put in. There should be 4 screws total. There's one between the X and Y headers, and there's one by the E1 driver socket, or the stepper motor socket, and there's one pretty much in the middle of the board, and there's another one in the middle towards the edge. So you want to make sure you put all 4 back in. Yeah, 32-bit, there's not a huge benefit of it on the Cartesian machines, or even Core XY. Core XY even runs great on the 8-bits. So, of course, I dropped a screw in here. Come on. Trying to grab it out, it like fell on the board in like the one spot where it can get stuck. I thought I had, yeah, I'm like I know I have needle nose pliers here. I was just using them. There we go. Well, some people can get luck with prints on glass. I can tell you personally that I have not had good glass or good luck with just glass. You have to use some sort of adhesion. And the only reason not to use it is if you're just trying to save every single penny and not spend money on adhesives. And in that case, I ask, why are you in this hobby? So it's not a cheap hobby to get into and stay into. So we're just going to reconnect all the connections, the bed thermistor, all your motor connections, and then I'm also going to run the new motor in for the second E motor. So I'm just connecting these back how they were. We got our Y. And I apologize for the lack of lighting, but I got to get more lights in here. This is what I have to work with right now. Alright, the original E goes to E0 just like it did before. And this one has the 2 separate Z motor connections here. So that's Z. We're plugging these back in. Alright, so there's all our motors connected. And I just realized I should have connected the power to the main board before I put it in, because it's a pain. You can do it, but it is such a pain to get it in with it out of the machine, or with it in the machine. So our negative, I'm just referencing the old board, our negative is the further one on the left. And I'm going to go ahead and open up these screw terminals by unscrewing them all the way. I can't really comment on the Olsen Ruby, and I don't really want to say anything bad about it because I've never tried it. But my favorite, like, more expensive nozzles, there's a company out of the US called T3D, and they make some really nice nozzles, and their most expensive one I think is like in the $24–25 range. It's their Hercules, they call it, and that's a coated hardened steel nozzle, which is funny because E3D is coming out with their own coated nozzles. All right, so is that in? All right. We got our negative wire in. Oh, what's up, Scott? How's it going? You need to stick down the Easy Mat. Do not run it with clips, because what's going to happen is as your print curls, the whole reason we have adhesion and we have all these different things like, you know, build tack, the Easy Mats, glue stick on glass, hairspray on glass, is because your print, as you're printing it, oh, that didn't grab it at all. It's going to warp, and the goal of whatever you're putting on your bed is to keep your print as it's curling on the bed flat as possible. So, you know, that's why just on glass it doesn't work, because you're just relying on the sheer, you know, force of the plastic on the glass to keep your print down. You need some sort of adhesion. And just because some people online can do it doesn't mean you're going to be able to, because you could have a completely different type of PLA from them. And, you know, just in my experience, just with even mats, I've noticed some brands stick better to mats than others. And, you know, it's going to be the same with the whole straight to glass type of thing. So just keep that in mind. Just because someone online you know, said they can do something doesn't mean that that's gonna work for you. But in my experience, I've had to use something on the glass every single time I've printed with glass, which has been a while since I've actually printed with glass, because I just got tired of spraying things with hairspray. I'm trying to, oh, here it is. I was like, I know I have my Z limit switch somewhere here. I'll go ahead and connect that up. All right, so what I want to do is, so we've got, if you guys can see in here, and this is on the other board, so we got our headers here. So we got our heated bed, we got our heater 0, I believe. Yeah, that's heater 0, which is your first hot end, and heater 1, which is the second. And the stock CR-10S board has this output on it. It's just lacking that one driver. So one little part is what's preventing you from being able to do dual extrusion on that machine. Just one little part. So I reconnected the fan. I know this one is the always on fan. He had his layer fan here, which goes to the one actually labeled on the board fan, because that's your controllable fan output. Go ahead and plug that in. And then we've got our heater wires, which are tinned with solder. So we're going to go ahead and get rid of these and strip them, because whenever I do work on a machine, I make sure it's up to spec and nothing is overlooked, because, like, you know, stuff like this can cause you issues down the road. It may work okay, but you know what? The proper way is to strip the wires into these terminals, not solder them. So that's what we're going to do. We're going to do it the correct way. Dual extrusion is mainly for people that want to print, like in this case, this guy's going to be using it for doing two completely different materials and doing soluble supports. He has like, I think 3 or 4 Ultimakers. So he's got some other high-end machines. This is kind of his screw around with machine. And he brought this to me because he was having just so many random issues with it. He's like, you know what? I was going to do the upgrade anyways. I don't need this printer for production. So I'm going to go ahead and send it to you. And, you know, when you get to it, you get to it. So I'm getting to it right now. And I figured I'd share with you guys the whole process. So I'm just reconnecting the heater wires here. And I got them into the right holes. Can be kind of hard to see if you're not used to working with these boards. So those are all the way in there, and I kind of give them a little tug just to make sure they're actually fully seated. And then we've got our new heater wires here, which I know these are these red ones. So I'm going to twist these, and then those are going to go into the heater 1 output. So I'm putting that into there, and then we're going to go ahead and tighten it up. All right. All right. Let me just check the. Was checking. Why don't I stream on Twitch? Because no one watches 3D printer stuff on Twitch. Twitch is like a barren desert for anything 3D printer related, so I don't waste my time streaming there. All right, I got my heated bed MOSFET connection. That needs to get connected next. I'm just trying, like, working with half the thing is like fighting with these dang wires in here. I'm just checking the polarity. If you look on the back of the board, if you ever forget, they're labeled plus and negative. Now for the heaters, it doesn't matter, but for the MOSFET on the Creality one anyways, it does matter. And again, these wires are tinned, so I'm going to snip them and strip them. And the main thing, like the heated bed, since this is going to the MOSFET, there's really no current going over it, so it probably would have been fine. But like I said, I'm in here working, I might as well make sure everything's done correctly. I'll go ahead and tighten this down. That benchy took about 30 hours to print. That was at a 0.6 layer height. And that's including the time it was paused, because it did run out of white and it sat there waiting for filament for a couple hours. So, all right, we got our bed MOSFET connected. And these are our power wires. I want to make sure these are out of the way here so I can reconnect them easily. And that goes to the bed. Those are all looking good. All right, so I'm going to take my second E-motor wire, which I set right here. And I'm going to put this through the grommet in the back. And this is going to be a tight fit because there's a lot of wires going through here. I find it helps if you turn the plug on its side and then push it through. All right, there we go. We got our second extruder motor, and this is going to go to E1. And I've got to hook up my Hotend wire. So luckily this guy color-coded his plugs because he had swapped his board. And brown goes to TH1, which is the Hotend #1. And then this goes to the bed connection. So, and this has red on it, which is what he put for the heated bed. And then we're going to connect the LCD. Now remember, we've got these always on 12-volt connections. He's got his fans and the Easy ABL kit power. And we got to reconnect those to an always on. So on our board here, we got our EXP1 and EXP2 headers. And EXP1 is the one to the right. So we got EXP2 and EXP1. So those are LCD connections. So we should just have our always on 12 volt, and then I got to run one more wire for the thermistor. And I got to see if this is the newer version or the older version, because one of these thermistors don't have one of the versions. This is the older Hotend, I think. And that we had one that had just a slightly different style, and I believe that comes with plugs on the end of it. I'd have to check our stock, but these do not. But we're going to do the same thing we did. We're not going to need all the wire on the thermistor, so I'm going to take these and, you know, fold them in half. And on the one, I'm going to cut half the wire off because we're going to be splicing this into the rest of the harness. And I'm going to use this other wire to make the connection to the board. Now, since these do not have ends on them, you can do it a couple ways. If you got DuPont connectors, you can crimp those on. If you got little jumpers, you can crimp those on as well. I have a 2-pin connector. This is one for the power, which I'll probably use for the 12 volt. No, I'm looking at, yeah. So we'll use this for the 12 volt. And I had another one set aside for this project on my desk here. I don't know where it went, but I had a little 2-pin white thermistor JST sitting here just for this project. I'm trying to find it. I'll steal one off this MOSFET here for now. Can always replace it later. These are all just 2-pin JSTs, nothing special. So, alright, now for the thermistor, it does not matter polarity, so you don't need to concern yourself with that. Now, just for consistency's sake, since these, I'm going to use one of these for the always on 12 volt. I'm going to swap these because they are actually reversed in terms of which side's positive and which side's negative, and I don't want the next guy to come in here thinking that red is negative, or red is positive when it's negative. So I'm going to just repin this connector real quick here. If I can get the pins to come out, maybe it'll come out easier on this other one. And when you repin the connector, you're pushing in on the little metal tabs here, and then the actual plug will slide right, the metal part will slide right out, and then you can pry it back up with the flathead and then push it back in so you can repin the connector to the direction you want. So there's like little locking tabs on these, and usually you can just get your fingernail under them, pull them up a little bit, and then you're good to go. This one's being a pain, but I got it. Alright, so on this one, I want my positive to be on the side closest to me. So I'm just putting these back into the plug here. And there we go. Here's our always on 12 volt, which will then power the 2 fans and the ABL kit. Now for the thermistor, we do not need to worry about polarity because thermistors are not polarity sensitive. So I'm going to go ahead and grab the wire I cut off of the other one, which are these white wires here, and I'm going to solder these up real quick and then make it look all nice and heat shrink it. Now, because the end of these are tinned, I'm not able to get the wire strippers to take them off, so I got to cut the tinned end off. There we go. Just like butter. I've got my heat shrink here, and I like heat shrink. It makes it look a lot cleaner. Easy ABL, well, I'm pulling, so there's always on outputs on your board, so I'm tying into those just for simplicity's sake since I have a free one in here. But it needs to be the power you can pull from wherever is always on, and the Z always goes to your Z end stop. But for power, you can pull from wherever you want, as long as it's an always-on connection and it's got a solid connection to that point. So I'm just putting my heat shrink tubing on here. I usually put them on the wires before I start working with them. Luckily, these are open end right now. So if I forgot to do this, it's not a big deal. But if you got a plug on the end and you go to heat shrink it, you're going to have a bad time because you're not going to be able to fit the heat shrink on. So I'm just going to twist these together and I'm going to solder these up. Anytime I'm working on a customer machine, we always solder everything, just because I don't want to have any connection issues down the road. I solder all my stuff just because I've had too many issues where if I just, you know, quickly, what's the word I'm looking for? If I just quickly twist it together, and even though it may be a decent connection, I always have problems later on, and they're not worth it. So, the artillery, I'm trying to work out some details with the company that's making it because they're getting discouraged because they do sell a, you know, what I would call an even more base model than what we have, because the one we have was one-off done for us, and he's getting discouraged because he's having a hard time doing the after-sales support with customers. So I'm still trying to work all that out. In terms of a printer, it's going great. We actually have it printing parts for our customers right now. And bear with me if I swear a little here, or swear while I'm soldering, because I don't know where my leaded solder is, and I'm having to use lead-free solder. And if you guys have ever soldered with lead-free solder, you will know how frustrating it is to work with. So, which is what I'm working with right now. It's always kind of a pain to get a nice solder with the lead-free stuff. You talking to me? Big order coming your way? Well, we should be good. Oh yeah, I don't know if you guys know, but Tyler is out of commission right now for I think at least another week. My AC is blowing my lighter out that I'm using to shrink with. He had his tonsils removed, so we're kind of just having to use any of our friends that can help us out. So we've been kind of scrambling here. And if you guys don't know, if you see, so Mac MCM in the chat, that's Mac McMillan. His real name is William, but he likes to go by Mac, so call him Mac. And he's our full-time support guy. We actually hired him. He's on full-time with us now. And if you guys see him, welcome him, and be nice to him, please. It's hard finding people that know 3D printers. So I'd rather not have to deal with him quitting because people are being difficult. Because it took us a while to find someone that actually has the knowledge of not only our products, but 3D printing in general, which obviously you know is important to this business. So I'm just heat shrinking all my wires, so I soldered them. I could tape them, but you know what? I've actually been using heat shrink a lot more, and it's just so much nicer. Like, we got a nice little pigtail here. Like, that just looks nice. That's what I prefer. Gives it a nicer overall finish. Alright, now I'm going to put my other thermistor wires through the back here. I got one. This grommet's pretty tight, but I got them through. I'm going to pull them through, and this is going to go to TH2, which is our second hot end connection. So there we go. Last but not least, we're going to go ahead and get our always on 12 volts connected. So in this case, we've got quite a few of them. What I'm going to do is I'm going to twist all these together that are the outputs, and then our input voltage that will power these is going to get spliced on. So and this can be done quicker. It's taken me a little while longer because I'm also talking to you guys. So and I'm just making sure I'm doing everything correct. Like I said, like this is going out to a customer. On my machines, I wouldn't say I take shortcuts, but stuff might not be as pretty looking versus when I do a customer build. And I just want to take the extra time because I don't need someone getting all pissed off later down the road because like something wasn't all nice and tidy or it looks kind of ugly. It reflects badly. Regardless if it works or not, it reflects badly. So I want to have nice work done. So I just like to take my wires, I take the two ends, I kind of crisscross them, and then when I twist them together, I kind of roll them over each other. So it gives it a nice mechanical, like you can see here, like I'm tugging on it, it's not coming apart. And then when you apply the solder to it, that just further solidifies the connection. So I'm just using the weight of the wire to heat it up. Come on. Usually I have the helping hands out, but there's not really much room on this table. All right. Just want to let your solder flow in there all nice. Make sure you get a nice connection. If you guys have never soldered before, the smoke you see coming off of that, that's called flux. What that's actually doing is cleaning the surface area that you're soldering onto, so that way the solder actually adheres. That makes a good connection. And when you heat shrink, I don't know if you guys noticed, you want to keep it moving because you don't want to overheat any of the wires and you don't want to burn anything. So keep it moving. Sometimes I'll even go higher, but this stuff is so small, I find it needs direct heat. So there we go. It's not going to short anything out. It's all nice and soldered. It looks good. And it's functional. I was just double checking the polarity on there. Let's see. Work part-time for filament. Might as well just pay you because we don't sell filament, so I'd have to buy filament to give to you. And accounting-wise, that would be very that would be kind of hard to figure out. And the nice thing is, even if I didn't have my ground strap on, I mainly want, like, obviously this table is not really well grounded, but the soldering iron is actually an ESD safe iron, so it will not cause any sort of arcing or sparking because the actual tip and everything is grounded, which is nice. We've been taking ESD precautions here because we have noticed some like opto ICs have gone bad. So I've been actually, you know, it's kind of a joke. Like most people are like, oh, use a grounding strap. It's kind of like I was like that, but it's, you know, after I've lost a couple things, it's like, well, I don't know why this component failed and it's probably ESD. I'm like, okay, well, I'm going to take these extra precautions and make sure that there's no ESD. All right, so I'm just double checking my connections that I got everything. I'm going to come back and zip tie this all up later once I know that everything's working. So I'm just going to make sure nothing's touching any of the fan blades. So when we power this on, it doesn't make a loud chattering noise. But everything's all good. In here, we've got, so coming out of our control box, since this is the dual hot end, we've got an extra set of heater wires, and we've got an extra set of thermistor wires. So this soldering iron I'm using is a Hakko FX-888D, and it's amazing. It's $100. I was always buying cheap soldering irons, and I can tell you that buying a good iron is life-changing. spend the money on a good soldering iron. That's I can't say it enough. It's worth spending the extra money on and Hakko is one of the best. And $100 for a Hakko is dirt cheap because Hakko makes some really good irons. I've got some other off-brand ones here. I've got like an AOE, which I've had to replace twice now. So I won't be buying that brand anymore. And that was like a $200 iron as well. So it wasn't that cheap. And I've also got one by Yihua, Y-I-H-U-A. And that one actually is the one we use to do all of our kit assembly. And it's ESD safe. And it's actually ESD safe. It's not just like they slapped the label on there. It's actually got the grounded tip and everything. And it's got a reflow on it. And I'm very happy with it. But the FX888, if you want just solid soldering iron, because that's what this is. It's just a solid soldering iron. If you want just an iron that's going to last a long time, the 888 is the best $100 I ever spent. And that one's 2 years old. It's been banged around. It's what I made, like, I probably made over 1,000 Easy ABL kits with it. I use it for doing stuff like this. It's my go-to for an iron, and it's not too bulky to where I can't bring it around the office. I do have a cheaper Yihua iron here that's an adjustable one. It's not digital, but it's adjustable temp. I don't know how accurate the temps are because I've never verified them, but I think I paid $35, $40 from it, but I would highly recommend getting the Hakko just because Hakko's a very good brand. Buy it once. I haven't used the cheaper one enough to know if it's actually going to last. And it's kind of the one I take with me places, the cheaper one, because if it gets broke or lost, I don't really care. It was only $30. And I've gotten a decent amount of use out of it. But I think this Hakko I want to say it's either a 70 or 75 watt. And then for doing beds, if you ever tried to solder an aluminum bed, you'll know how terrible it is to try and solder those because the amount of heat you need is just insane. I'm trying to make sure I got all my connections here. I got my bed. Okay, I was like, I feel like I'm missing a positive. I should have 3 positives. One for the bed, one for the board, and one for the MOSFET. So I'm just reconnecting my 12-volt connections here. And once I'm done with this build, I'll go back here. I'm going to tidy these all up. I'll do that off camera because I don't want to be doing that on this little table. I want to really get in there and zip tie everything up all nice. So cable manage your wires when you're done. So I'll make sure everything works and then go back, cable manage your wires. I found it's just easier to do it after the fact versus trying to do it while you're getting the bulk of the work done. Just go back, because if you ever have to remove a wire or move a wire, then you're going to have a bad time. So, alright. Now I got that. Now I'm going to make sure this thing powers up, because this should power up at this point before we go any further. Well, alright. Let me double check my connections here. Yep, line, neutral, ground, we're good. Oh, he's got a fan going out. His power supply fan is toasty. Do you hear that? But the board works. Yeah, his power supply fan is shot, so I'm gonna replace that. I'll replace it after we're done, but I'm not sending him back a printer with a busted PSU fan. Or I'll see if he just wants to upgrade it, because we do have the main wells in stock, and they're a heck of a lot better. But his PSU fan is shot. So if you hear that noise, that means your fan is screwed. I'm gonna take this off at this point, because we don't need it. I'm going to move some of this stuff out of the way. Alright, so I've got my new connections here. Yeah, see, there was just all sorts of stuff in this case here. Because he had been in here putzing around with it before I was even in here messing around with it. Alright, so I did have some sleeving. Yeah, the sleeving I took off these, which is kind of long. Yeah, I'm just going to zip tie these. So usually what I do is I'll just zip tie these to the existing wires that would go up the hot end. So we'll just zip tie these together, and then I'll zip tie the other ones coming down. So for quick disconnects, what am I going to use? He had a bunch of stuff in here. What goodies does he have? Because he literally just handed me an entire box of crap. It was like, this is everything I bought with the printer. Looks like he has a thing in here he tried printing with a really crappy fan. Looks like he's got, I'm assuming this would probably be another PSU fan, but these are just cheap little fans. They're nothing special. So what has he got in here for me? What do we got connector wise? He had a bunch of crimps on here, but I don't even have the tool to crimp these. I don't think he put the tool in there either. Yeah, I'm not seeing them in here. He does have these nice little connect buses here. And some crimp terminals, it looks like. Yeah, I'm just going through here and seeing what goodies he's got. Yeah, I don't have the tools to do DuPont crimps or anything. I don't think he put them in here either. He's got a lot of random stuff in here. Yeah, it doesn't look like it. It's got these weird, I don't even know what these are. It's got these weird like push fit connectors here. Looks like. Haven't seen these. They're labeled L and N, so I'm assuming they're used for AC power, but I've never seen these before. I've dealt with a lot of crimp connectors. Alright. Oh, he actually had some 2-pin JSTs in here. Oh well. Alright, what was I going to grab here? Oh, I was going to grab some DuPonts for the thermistor connection here. So we're going to put some DuPonts on so this can be disconnected and reconnected. So basically he can still disconnect the control box from the printer. And actually I've got these nicer ones here, so we're going to use these. These are already pre-wired with ends on them, which is nice. So all I have to do is solder and heat shrink them. I just got to find the female part that they actually go to. And I think he had some XT60 connectors in there that I can use for the hot end heater. Because you want to use something that's got some skookum to it. And I'm just trying to find this dang female end, and I can't seem to find it. Got another male end. And here's the thing, I know I bought I know I bought equal amounts of each because they came in a pack and they had the same quantity, so in theory there should be the same amount in here of male or females as there are males. If I can find it. So this is what you guys would normally not see when I'm trying to do stuff, is me searching through all my bins of crap to try to find what I'm looking for. Finding the female is always a problem. Funny. You guys are funny tonight, apparently. We got a comedian. There we go. I found the female. All right. So we're gonna heat up our Hako again. And we're gonna get some connectors on here, make this look all pretty. I don't know if you're new to the channel, but this is pretty clean. And the name Morwick sounds familiar. Where would I recognize that from? I feel like I've heard that before in the 3D printing space. Alright, so remember I said about putting your heat shrink on before. This is one of those times, because if you forget now, you're not going to fit it on later. So I like the little pre-cut heat shrinks. Oh yeah, Marwick. Yeah, Frank. I was like, I know I remembered that. I was like, what the heck? You know, you hear something, you're like, I know it's familiar, I know that, and then you completely blank. That's what I was doing. Yeah, I talked to you on the phone a couple times, and I know my wife has as well. So, yeah, these are awesome, by the way. You guys need to get yourself a pair of these. Vice Grip. If Vice Grip wants to send me anything, I'd be happy to show it on the channel. Just saying. Shameless plug there. In case I want to sponsor me. Could always use some awesome tools. Because I know I really should put together, I don't know what you guys think, because like I know like so like if you guys ever have heard of Louis Rossmann, he runs an electronics repair company, and he streams a lot of his repair work that he does, and he also has like on his site or on his like video description, like he's got links to all the stuff he uses that are like affiliate links, so he gets, you know, some kickbacks from it, and people get to, you know, use good products that he recommends and personally uses. I don't know if people would care what I use, but maybe that's something I should put together, because I feel like that'd be helpful. There's a lot of crap out there. So got the helping hands out because that's what they're for. They're to help. See, if this is leaded solder, this would have flowed out in like 2 seconds, but man, lead free is just not, it's not fun to work with. It works, but I don't like working with it at all. I'll take my lead cancer over a good clean solder. Yeah, that's the guy Apple tried to sue. Yeah, for showing people how to repair their hardware. You know, we're getting upset because, you know, software is not open sourced when it should be, and Apple's over here attacking people trying to fix machines because they're basically telling their customers, you know, go piss off or pay us, you know, an insane amount of money. Like that's messed up. I'm surprised you say Apple blows. Usually you music guys are all over Apple. These sort of creative types are all over Apple. I hate Apple. I will not buy their products. Like mainly because they're a bunch of assholes. Like they're not a very nice company. I remember seeing like when Steve Jobs was going through all this stuff, it's like, you know, he never gave it charity and stuff. You know, you got people like Microsoft, but you know, you got Bill Gates. You know, what is he doing in his retired days? He's doing charity work. You know, it's like, you know, he's giving back, and someone's like, well, maybe Steve got, you know, taken out of the running because you know, he's kind of an asshole and he never gave back. It's like maybe that is a possibility. I thought it was interesting, you know, because people love to hate on Bill Gates because Microsoft is evil and all this other stuff. But you got the guy out there, instead of just taking his time, and, you know, relaxing. He's out there doing charity work because it makes him feel fulfilled. So, all right, so I'm going to put on my connector here for the heater. And like I said, I'm pretty sure I saw some XT60 connectors in that guy's box of goodies. So if that's the case, I'm going to put those on. I think I have some in my bin. If not, I definitely have crimped spade terminals, which are more than enough for the few amps that your Hotend will pull. All right. Let me see what he's got here in his box of goodies. He's got these interesting ones. 10 pairs Tamiya big style. Let's see. Can we make these work? I really need to, that's one of my list, it's one of my tools that I keep forgetting to pick up, is like stuff to crimp connectors on. Like, I keep forgetting to order them because that would have been nice to have these here. All right, let's see how these work here. I haven't dealt with these before, so looks like we got 2 females and 2 males, so we're gonna go ahead and clip off the ones I need. Looks like I should be able to. I'm gonna crimp these around the wires, and then I'm going to crimp these around the wires, and then I'm going to solder them. Solder, just to make sure they're 100% in here. Oh, that worked nicely. Okay, I can get down with this. All right, crimp them over the insulation. You guys can see what I'm doing here. I'm just putting these little ends on here, and then I'm going to put a drop of solder on there to make sure that it's all connected up nicely. These are pretty nifty. I wonder if these are meant to be clipped off, this end here. Looks like these are just part of the metal that holds them on the strip before you actually crimp them on. Alright, that looks much better. Alright, I'm going to just put some solder on here to make sure that this is making a solid connection. There we go. Just sucking the solder up real nice. All right. That wire ain't going anywhere. For crimping, solderless terminals use Thomas and Betts Stacon lug pliers. If you want to send me a link to those, can you email it to me, Tim at TH3Dstudio.com? Because that would be great. Yeah, I just used normal pliers and it worked. And I soldered it because I know I'm not going to get as good of a crimp as like a machine would. I think I'm putting these in the wrong plug. Let's see here. Let's push that in. And it locked. Okay. Well, that's nice. It almost looks professional. Look at that. It was, I think, 5% is what I set it to. Yeah, this went together nice. All right, I'm gonna do the other one. That was very nifty. I like this. Yeah, and like I said, these normally would be solderless, but because I don't have the thing to actually fully crimp them, I'm going to put some solder on here just to make sure that there's no chance this wire can ever come out of this terminal. Dare I say it'll be a better connection than if it was crimped. All right, let's put that in there, get some solder in there. Yeah, this is actually branded on the packaging as an RC connector. And even though I have to solder these are more than enough for the hot end here. And XT60 soldering those is always a pain. So I'll deal with these. These are going on nice, real nice. I'll have to pick up a set of these to keep around for projects. I'm just going to push this in here. And you can hear the connector like clip in. All right, these aren't going anywhere. So there we go. We got our plug, and then we'll put the other end on the other set of wires going to the other hot end. So this will go in like so, and then lock on, and we'll have a nice sturdy connection here. The only question is, where did I put? Oh, they're right here. I was like, I knew I was missing the male ends here. Yeah, these are pretty nice. Apex RC Tamiya plugs is what this is what they are. 10 sets Tamiya plugs. Not bad. I like them. I like them a lot. All right, so you know what I'm going to do? I'm going to make it look nice. We got some extra heat shrink here, or not heat shrink, but sleeving that we took off of the bundle of cables. I'm just going to put these over this, make them look all nice. Probably should have put this on before I put the plug on, because this is going to just make it harder. Well, this one works, and this is going to work for the hot end, and the customer supplied them, so I'm going to use them. I like them. I've heard of Tamiya plugs before. I never actually used them, but all right. Let me see how much of this braiding I'm actually going to use, because this is a little longer than what I actually need. So I got about that much. So when you guys, if you guys ever cut braiding, okay, what you got to do is you got to cut it, okay? And then if you don't want it to fray like crazy, you take your lighter and you just melt the tips a little bit. And that'll keep them from fraying as much. And then usually what I'll do is I'll wrap electrical tape around the end to keep it from fraying even further. So just a little tech quickie there. All right, I'm just going to slip this sleeving back into the control box. There we go. I'm going to pull this down a little bit and push a little more in. And now we got a nice extra cable for our hot end. All right. There we go. And I'm going to, like I said, I'm going to put some electrical tape around the end here just to make it look nicer, and it'll keep that wire from fraying. Now you can use heat shrink. I don't think I have heat shrink large enough, so in a pinch, electrical tape works fine. And I'm just going to wrap this around the end of the sleeving here to keep it from fraying. And there we go. Doesn't look too bad. All right. Yeah, if I don't know if I think I have some shrink in there, but one, I can't fit it over these wires. I wasn't planning on heat shrinking it. And two, the electrical tape works fine in a pinch. All right, so we've got our heater wires ran. We've got our extra E-motor cable ran. Now remember, we're going to have one thermistor that's shorter than the other. That's going to be the one we splice into the existing harness. And then we've got, again, one heater cartridge that's shorter than the other, and that's the one that will get spliced into the existing. We want the one, I'm going to set the ones with the longer leads over here, and we're going to go ahead and start taking apart the hot end. So I'm going to move the control box down here so it's out of our way. And then I've got our connectors over here for the second hot end and thermistor for when we get to that point. All right. So we're going to start by dismantling our existing hot end here, which you guys can see. Go ahead and take off his bracket here for his ABL sensor. And we're not going to reuse these washers. These are just included in some mounts that need them, but the one we're going to does not. So we're going to put those in the bin. And he's got a random clip on his cable there for some reason. And this whole thing needs to come off. Yeah, that's another thing too. If you heat shrink it, you're not going to be able to get it off very easily. All right, so now he has the stock Creality fan on here. It looks pretty clean, so I'm assuming it probably works. I'm just going to unscrew his fan because we're replacing this whole hot end assembly. It looks like he might have a micro Swiss on here. I don't know if this is an actual micro Swiss or a clone. But all right, we got our hot end always on fan, which is our cold end heatsink fan. We're going to keep this because we need this, but we're going to snip the wires for our layer fan because the layer fan is getting replaced with a 5015. And it looks like he's got Phillips screws in there, which he definitely replaced this hot end then. And you can see here he's got, I don't know if you can see on the top, but he's definitely had leaking coming out of there. So I know he said he was having a ton of hot end issues, and then he originally wanted me to take a look at it, and then he was like, you know what, just upgrade the thing, do a dual setup, and he's like, that'll fix the hot end issue because we're going to completely replace the hot end. And he's not wrong there. So we are fixing the issue by completely replacing it. I don't know if we'll be printing any emoji poop today. All right. Now, what I'm going to do here is we're going to take apart his extruder because he's not going to be using the extruder that this has. We're going to dual tough extruders, which are based on the Titan design by TH3D. They're just a little more affordable. And we're getting rid of this standard MK8 style, which they work fine, you know, but, you know, if we're going through the trouble of upgrading all this, we might as well just completely change everything. So, all right, so we're going to take our Easy ABL kit. We'll get that off to the side. I got this hot end here, which I'm going to pull the insulation back, okay? And we got our existing heater cartridge and thermistor. Now, we could use this one, but I don't know the history of this one, and I know the one that I'm putting on works, so I'm going to snip these right here, and we're going to leave this like this. I'm going to give this all back to the customer. So if he wants to have it as a spare or use it, he can always resplice those wires in at a later time. So I'm going to set this over here. And then I'll have to go back and grab all this stuff. So now you can see the wires pulled back into here. So what I'll usually do is I'll grab these wires, I'll pull them back, and then we're going to go ahead. Normally I put electrical tape, but he actually had a little binder clip. I'm just going to put this on here to keep the wire loom from sliding back down. All right. There's still tape on our Easy ABL here, so I'm going to get that off. And he actually followed all the directions. There's no zip ties holding the sensor wire on, so I don't have to worry about that. It very likely works correctly, and we'll find out. If for some reason he does have an issue with the kit, I can easily swap it out because I have it. Yeah, what hot end would you recommend for a CR-10S? It really depends on what you want to do. If you just want to print PLA, swap the tubing out with something like the tough tubing like we sell, and you can get a little more longevity out of it. If you're printing, you know, under 275, that's an easy way to upgrade it. But I like the tough hot ends we sell. Those are similar to the V6 that you'll see. You get a lot more bang for your buck on them, and even a longer warranty too, which is interesting considering we have longer warranties on a clone than the actual original company. So, all right. Now for the mount here, we're using the Pet's Fang. I accidentally knocked out the support here, but it's not needed, so it doesn't really matter. And this clips on like that, and then we're gonna have 2 screws that go into the mount, and then another one over here, which is also going to hold our ABL sensor. So now's the time where Tim starts looking for screws that fit. I'm going to try the ones we pulled out of the existing hot end here and see if these are long enough here. Yeah, the Noctua fans are not a good choice because they don't move a lot of air. That's why they're so quiet. All right, so these worked. I go ahead and grab another one of the same length. And put that through the hole. Now, when you're changing your hot end mount, a good thing to have is an M3 screw assortment, because no matter what you encounter, you're going to have something that can go ahead and put it together. So, now the tough dual hot end does come with a fan, but in this case, we're going to use the existing 40 millimeter that comes with the machine. And I got to put these 2 little grub screws in. These are, like I said, this is the slightly older version of the tough hot end that has the set screws for the heat brakes on the sides. The only difference between this one and the other one is the set screws are on the rear. Or, actually, no, am I getting that backwards? Oh, sorry, this is the newer one, duh, because this has them on the sides. I was like, I thought we'd changed it to we changed the manufacturer to use ones that have them on the sides. I was getting that backwards, because they used to be on the rear. And dear God, trying to adjust that, good luck. So yeah, we have them on the sides now. And it's been a long day. I was trying to help my parents get their laser cutter going, which I don't know much about them, to be honest. I have one, and I still have yet to power it up. And I was trying to help them with theirs to see if we can get it going with light burn. But apparently the board in it doesn't support standard G-code, and you have to use the proprietary stuff that Full Spectrum has, which they have not had luck going. They've got a $4,200 laser cutter that they haven't used that much because the software is so bad. So, yeah, closed source control boards are bad. If that doesn't translate over to 3D printing, I don't know. I don't know what else to say on that matter. All right, so when you're putting together the dual hot end, you got your set screws on the side. Sometimes they might be floating around the bag. You want to make sure you got 2 on here, 2 on here, and then you've got mounting holes on the top, which these will go into the top. So we're going to put the block up through here, and there's 3 holes up here. Now, before we put this together, I highly recommend that you go ahead and put the heat brakes and everything in. So I'm going to drop these in and make sure that those go all the way through. And I just realized this was the one where these are just the PTFE heat brakes. I don't have the steel ones here, which is what I was going to put in. So I'm going to go run and grab the steel heat brakes that usually are in here and put them on this one instead of the PTFE pass-throughs. So I'll be right back. All right, we're back. And I'm actually going to hook him up with the titanium ones, which I haven't listed on the site yet, but we got really nice titanium heat brakes for these. So in theory, so if everything fits together nicely, like you see this is fitting together nicely, everything's flush, you shouldn't have any issues. So I'm going to assemble this and then see how the level the nozzles are. So I'm going to tighten the set screws on the side here, which will secure the heat brake into the block. And the reason you have the set screws is if you need to level your nozzles, you can just loosen up the set screws and the whole heat brake will slide down. So that's the logic with those. So I just tighten those down. These are not going to come out at all. They're not going to turn, not going to come out. Now, I know because of the bolt here on the carriage, I have to have this heat block facing this way and the other one facing that way. And I just realized you can't tighten the, you can't tighten or put the block on if the heat brake doesn't spin. So basically put your heat brake and nozzle together, and this goes together similar to the Tough V6. So you got your heat brake and then your nozzle is going to go in here, and we're going to hot tighten this. So I'm going to put my nozzle in, and I usually go all the way till it's flush and then back it out about a half turn. So you have this little gap between the nozzle and the block, and then I'm going to tighten the heat brake just finger tight for now up to the nozzle. Okay, and what we're going to do is we're going to heat this up to 260°C, each one of them, and then that will basically make all this stuff kind of bond and mesh nicely together, and the heat brake is going to seal up against the heat block, or the heat block. Can't talk. The heat brake is going to seal up against the nozzle so you don't get filament leaking. So like I said, this one we want to have facing this way, not this way, because I believe it's going to hit the little adjustment, or the little screw here. The bolt, oh no, actually it fits. So that's convenient. All right, so we don't have to worry about that. It fits just fine. All right. I just remember reading something about that. People were saying they couldn't get it to fit there. So we aren't, it doesn't look like we're gonna have this issue. So I'm gonna go ahead and I'm gonna tighten up the set screws here, make sure the block is lined up, and just snug them. You don't want to go crazy. You don't want to strip out the grub screw here. Just get a little snug here. I have not looked at the Hotend for the T-Wolf Flash. I would contact them and ask them. They'll usually sell you specific parts if you ask directly for them. So, and when you're assembling these V6 style blocks, this is literally just two V6 blocks on here. You want the the bolt, which tightens the heater cartridge, facing down. So be mindful of that when you're putting your heat brake and everything together. So I'm just threading that in. I'm going to grab my second nozzle. And like I said, thread it all the way in, okay, till it's flush, and then back it out half a turn. And tighten your heat brake up to your nozzle. Like I said, I just do finger tight for these. Now, you will have to, one of these is going to be flipped, okay? So one of them is going to be going one way, one of them is going to be going the other way, and this is because your wires got to come out of one side. If they're both the same, your thermistor is not going to be able to come out. So it's going to be butt up right here. So one of them's got to be offset. And what I think I'm going to do, just because there is that bolt there, I'm going to offset this one if I can. I'm trying to think of how the wires are going to be. If the wires are coming out this way. Oh no, because they'll be out. So I'm gonna set it up like this. So basically you want the thermistor hole on either side. I'm gonna go ahead and align this here. And I'm just gonna snug this one, okay? I'm gonna snug one of these because I want to see if these nozzles are indeed level. And I know there's a way, so this one probably needs to come down a little bit. Maybe not. These actually look pretty dead nuts. All right. So let's tighten this up. We can always adjust it. It looks like we can adjust it easily because there's 3 screws on the top here, and that'll drop the whole hot end out. So literally 3 screws drop out the whole thing. So this will go up in here. There's 1, 2, 3 screws at the top, and then that'll be it. So I'm gonna put the fittings in at the top here. I don't know if these are gonna fit all the way through. They will. All right, so I'm gonna put the fittings in at the top here. And then these I just like to snug with the pliers. Just grab your pliers, give them a snug, because you don't want these coming loose. All right, and this goes up in here. So you can see, got our fittings coming out the top, and we're gonna take 3 screws and put in the top. And there are some screws included. I believe these should, I don't know how far down these are threaded, but let's see. We might be able to use ones included. Otherwise, he gave me a big batch of miscellaneous M3 screws. So like I recommend people, if you're doing work on your printer, just pick up an M3 screw assortment and have that ready, because it's going to make your life a heck of a lot easier. So 1.5, this is a 2.0. Let's say these should be 2.5s. Oh, there we are. Okay. So there's 3 screws. These are, oh no, these will be good. I was like, I thought it was not going through. It is. So there's 3 screws on top, and that's what holds the block into the actual hot end mount. And let's see if the one in the rear goes down as far as the one in the front. I don't know if this screw is shorter than the other one. I think it's the same. Should be the same. All right. It's the same. I don't sell M3 screw assortments because I can't compete with Amazon's prices on stuff like that, so it's not worth me carrying it. All right, let's see if this one will go all the way down. Just barely. It's not going all the way in, so I'm gonna grab a different screw for that rear one. He definitely purchased a screw assortment because this is the thing he gave me. You can see this here. Look at that. Isn't that beautiful? So I'm gonna use that. Let's see what we got here. We got some short ones in here, or do you just have long ones? It's got some shorter ones. This one should work fine. I don't run dual fans on any of my machines. I have a single 5015. And that does the job for 99.9% of people and use cases. All right, there we go. So we got our 3 screws in. You can see here, secures in from the top with 3 screws. And you got your PTFE fittings there. I'm gonna set his board off to the side here. So at this point, what we want to do is we want to put our heater cartridges and thermistors. So this is our first nozzle here. This is our second one, okay? So you want to put your heater cartridge in, and it's going to kind of stick out a little bit. I'm going to move my Z up so I can get some screwdrivers under here. And then we got our heater cartridge in there, and I want to have it centered so there should be a little bit sticking out of each end, and then tighten down the black screw here. And that heater cartridge should not move if you pull on it. So you did see here I turned the block a little, and that's against the heat brake, which is fine. It's going to move when I'm torquing these down. Now we're going to back this out a little bit. I'm going to put the thermistor bulb in the actual hole on the side, just like in the V6 Tough Hotend video I put out. And then put the little thermistor leads underneath the screw head. Just use your screwdriver to put them on there. Don't drop your screwdriver. And then tighten them down. Now now when I say tighten them, you just want to have the screw kind of hold the thermistor lead. You do not want to crank it down, because what will happen is it will break the insulation that covers the thermistor leads, and then you're going to get a bad reading. So, and because I was trying to do this without the screwdriver handle, it didn't go, so I'm going to put this, just kind of push these leads around the screw, and this will hold the thermistor in place. Now, what you can do too, which I've done before, is you can take like a washer and put a washer on the screw, and it'll just give the screw a little more surface area to hold the wire on. But as long as you get this in there and the insulation under the screw head, it's not going to come out. So, and I keep having trouble getting this under here for some reason. All right, let's try this. Push that down. All right, there we go. So there we go. We got our 1 thermistor and heater cartridge installed. And that's for our first heat block. Now I need to see how this duct goes on here, so I know where I can and cannot route wires. Okay. So I'm going to push these wires through the back here to kind of route them around and make sure they're not strained at all. And then they'll come out the other side. All right. Trying to think of what I want to do next. What do I want to do next? I want to splice in the 5015 fan. I'm not going to put this duct on just yet, because this is going to get in the way quite a lot. So I'm not going to put that duct on just yet. All right. So we got 1 heater cartridge, 1 heater set up. We can set up the other one, same process. And this will be our heater 2, which is going to have the longer leads on it, which is what we made the extensions for. So same process, put your heater cartridge in, And you're going to want to tighten down the black screw here. Like I said, since we haven't tightened the heat breaks down, these are going to move. So just kind of hold the heat block with your fingers and don't tighten it too much to where you strip it. You just want that heater cartridge to not move when you pull on it. Let me see here. Would you say microspec? I don't. They're all right. I have one here. I haven't had any issues with it. You're paying for a drop-in convenience with them, and if that's okay with you, they are good hot ends. I have no complaints. I just like these. Well, I use the 2-in-1 for a dual setup. This is a pain if you guys haven't noticed. Like if this was a 2-in-1, it would just be put the splitter on and mount the second motor and we're done. But this is a lot more work than the 2-in-1 setup. But this is a little more versatile because you can then print two completely different materials on the machine with completely different temperatures. So it really depends on what you want to do with the machine. You know, is really my answer to that. So the micro Swiss that fits the CR-10 will work on the Ender 3. They all share the same parts. And you see here, I didn't get the bottom wire underneath the screw, so I'm just gonna. These wires are like solid, so if you push on them, they will conform. It's the other thing I don't like about these style heater blocks, but the reason we have these styles is because they're cheaper. And once you get it all together, it doesn't really matter. So, but we got our hot end 1, hot end 2, and we got all our wires coming off. Now you're like, oh, well, how do you know which one's which? Well, I know the shorter wires are for hot end 1. Those are the ones we're splicing into the stock wire harness. So, I know that much. And it looks like I got to put one more screw in here on this mount. Longer screw too. I don't know anything about the U20 and what they have in terms of connections, so I couldn't tell you what could go on the U20 at this point until I get one in hand to actually use it. And I'm pretty sure the U20 is using a closed source board, unfortunately, so I don't know how much tinkering and stuff you're actually going to be able to do with it, which is one of the reasons I wanted to get it in here to try it out, because I want to see what exactly it's running hardware-wise, if it's, you know, violating any licenses in terms of the GPL, and what its pros and cons are. So yeah, there's another screw here that bolts the PET's fang to this carriage here. So I'm just putting this other bolt in here. PET's fangs are very solid mounts. I really like them. He's done a very, David Petzel was the author, has done a really good job of putting these together. I've got them on my Alpha Wise, I've got it on my Tivo Tornado, and they're great coolers. They're hard to print for some people though. So we got 58 people viewing. That's higher than normal, I would say. So now I'm just trying to see where do they route their 20mm fan wire, or 40mm, I should say, not 20. I'm gonna go up this way because it looks like I should have enough room on the duct here. So I put this in place. Yeah, I got more than enough room. All right, so I'm going to put the fan on, have the wires go up this way. I'm going to actually use 2 of the remaining screws from the tough hot end here. What am I vaping on? So I don't know if you guys see all the juice in the back corner here. My buddy works for a vape wholesaler, so he basically just gave me a bunch of juice. But I got this Blue Nam Enon. I don't know. It's some sort of blueberry blue raspberry. But it's tasty, and it was free, so you can't beat that. And while I was sitting here talking to you guys, I lost my screwdriver. This is my life, constantly misplacing tools. Alrighty then, where the heck did I put it? Had my vape. Am I just being stupid right now? Where the hell did I put it? I had my screwdriver literally like 2 seconds ago. Oh, it fell underneath the extrusion. All right. So I'm just threading these in. These are just M3 screws. These just thread right in to the thread these right in to the plastic, and they'll bite in very good. There we go. And you don't need to use all 4 screws on your fans. You can use just what I'm doing, one off each corner. Makes replacing it, if you ever have to, a heck of a lot easier. Although I wish I had one of those, like those cool screwdrivers you see. They're like open source screwdrivers. You can like reprogram. You just turn it and it just goes. Because these little ones are just, it's so repetitive sometimes, especially when you're redoing a whole machine. It's such a pain. All right. So got all our wires going back this way. I can go ahead and mount this. Let me see. Now I'm probably actually gonna wait. Looking at this, I'm gonna wait to mount this until I do the tightening, until I do the hot tightening, because this is gonna get in the way, and I don't want to break the duct with the. I want to break the duct with the wrench when I get in there. Just putting some stuff down there. Yeah, it's a gyroscopic screwdriver. I can't remember what the name of it was, but it was really cool. I've seen it on a bunch of like little tech channels that do teardowns and whatnot. I think AVE has one as well. All right, so I got my thermistor and my heater cartridges. Looks like a rat's nest right now, but we're gonna make short work of that. So these are my long ones. These are my second. So I'm just gonna hang these over so they're out of the way. And what I want to do is I want to cut these so they're all the same length as the other wires. And I usually like to put my splices up into the cabling or into the sheathing. So I'm going to go ahead and, since I got my 40mm fan, it's kind of a gauge. This one is mounted, so I know how long I have here. I'm going to go ahead and trim these so they're all the same length, so that when I go to splice it, everything is all uniform. Everything I'm installing comes in the kit. You will need some random connectors if you want to make your stuff modular, and an M3 screw assortment. So we're pretty much just supplying you the parts, the bulk of the parts that you need to do the conversion. This is very much a DIY set of parts that you can purchase from us. So, and there's no tech support included. So if you get stuck, you're on your own essentially, because we don't make much on the boards to begin with, because Creality sells them to us for so much. And if we charge more to include support, no one would buy them. So we just have them as, if you need help. There are guides in our communities already that other people have made to show you how to do all this. There's a couple 2-1 setups. There's a couple dual hot end setups. I believe they're in the Facebook group, the TH3D customer support group. If you search dual, CR-10S dual, there's a couple guys that did write-ups. And it really depends on what you want to do setup wise. You know, like this one has the ABL. This one has ABL on it. We're going to do a 50-15 fan. So it's very unique to your setup. So, and I'm just letting you guys know, if you guys do want the dual boards, you should probably, like, this is the last, this is going to be the last batch that we're going to be doing, because I'm not going to be supporting Creality and selling their products anymore, because they've just turned their back on the whole open source licensing. So the boards we have are going to be the last ones unless they quickly change their tune. I'm not going to keep giving them business of ours, especially after they knocked off one of our products. It was already kind of a weird relationship buying parts from a company that stole your product. So yeah, the dual hot end, we have the dual hot ends that comes with the heaters, the thermistors, the whole hot end itself. You will have to print your own mount. We do custom print requests. So if you want, you know, like a PETS thing, an ABS, if you can't print ABS, we do those. You just have to contact our support, and there's a couple day lead time on those, because we don't like have them sitting around pre-printed. We have to, you know, slice those up and set it up and everything. So, but we do printed mounts if you want an ABS mount. PETG works fine. PLA would work fine for the main mount, but for the duct, I highly recommend PETG, not PLA, because I printed the U10 duct originally in PLA. I thought it'd be fine, but after about an hour, the actual ducts were sagging so bad that I had to reprint it. So don't print the duct part in PLA. It will fail. I thought about getting the pallet too, but I've also got the M3D Crane Quad on the way, which is a quad color printer itself, and I only paid $540 for it. So I'll have an entire printer that comes out of the box that can not only do multicolors and multi-extrusion, but it can also mix them. So, and that was a Kickstarter or something like that, crowdfunded thing. I picked it up because it just seemed really interesting, and they do, you know, they have actually fulfilled their crowdfundings. I'm not a big fan of M3D though in general. Like, they have their M3D Micro, which is a steaming pile, but it looks like the new one, they've done a lot of stuff right on it. So we'll see how it comes out. It will be on the channel once we get it. And I paid $540 for it. So I got in on the first batch when it was only $540. They did raise it to $649. And when I had ordered, they said we would have had it this month, but apparently they pushed it back. So I'm in no hurry. If they don't deliver on it, well, that's going to really suck. You know, I would even take a, you know, not ready machine over nothing. So we'll see. Crowdfunding is always a risk. It was a risk I was willing to take. So we'll see what comes of it. If they actually follow through and deliver said product. I'm having a hard time getting this sleeving over this this wire, because it's got this, like, it's got that, you know, what's the word I'm looking for? The cloth insulation on here, but I got it. Like I said, make it look all pretty. We'll heat shrink it. If I can find my lighter, that'd be great. Can't heat shrink. That was my heat shrink falling out of the thing. It's like the third time I've done that. Alright, I'll have to pick that up later. Question is, where is my lighter? Oh, man. Alright. Oh, it was in my lap, apparently. Alright. Go ahead and shrink this. This is all soldered up. We're going to shrink this so it looks all nice. And I highly recommend soldering your thermistor and your heater cartridge wires. Fans, you can use you know, quick disconnect or quick connectors like the 3M ones we ship with our fans. You know, there's not a lot of current going through those. But But for hot end wires, I always solder them every single time. Hot and thermistor. And I don't solder the thermistor because there's current going through them. I solder the thermistor because I want a solid connection. And every time I've not soldered a thermistor, it's always come back to bite me later. Because like something came loose, if I just twisted it and heat shrunk it, something comes loose, and then I have to rewire it because it's triggering thermal runaways and all this other fun stuff. And fun tip, before you put heat shrink over a solder wire, make sure you close it, or make sure you cool it, because what'll happen is you go to put the heat shrink on, it starts shrinking because the wires are hot. I haven't used the MK3. I've heard hit and miss stuff about it. I will probably never own one because I can't, like, I would rather take a machine and modify it to do what I want. The Prusa is more of a turnkey solution. It's more of just, you know, you want a printer that works. Prusa is pretty good at that. So me personally, I don't think I would own one unless I could get a really good deal on it. So look at that. That's all nice. All heat shrunk. Look at that. So we're going to do the same thing for the thermistor leads here. Like I said, I take my time. I could probably be done with, you know, pretty much done with this by now, but I like to take my time, especially on customer builds, you know, which is why we charge so much in terms of labor, because I want to make sure everything's done right and done right the first time. You know, I don't like to pull a Creality and send out a half-finished product. So, all right, I'm just going to push the heat shrink up there so it's out of my way when I'm soldering. And we're going to go ahead and twist the wires. And again, the thermistor polarity is not, the thermistor is not polarity sensitive. So just wrap those up around each other, and then let's give it the old solder. When you're soldering, you do want to leave your soldering iron on the wire for a sec just to heat it up, because what that'll do is, if the wire is hot, it's going to let the solder flow into it a lot easier. And as I said previously, this is lead-free solder, which is why I'm having a harder than normal time working with it, because lead-free solder is a pain to work with. If you talk to anybody that deals with electronics, they will tell you that lead-free solder is just absolute horrible. It's absolutely horrible to work with. The layer shift, I think it was either a combination of low VREF and just the sheer weight of that thing, or it just hits something and cause it to skip. Also the nozzle, because I need to retighten up the nozzle to the heat block. I was getting some leaking between the heat break and the nozzle, so I'm wondering if maybe something dripped off the heat block and then the nozzle hit that instead of like curling, because I didn't really see any curling on the print. But I did see, like on the infill at one point, I did see that there was some nozzle leakage in the infill, and I was doing my best to clean it off and keep it at bay, but it was finishing up the top portion of the print when I was asleep. So I was like, okay, well, I'm not going to sit up and, you know, sit here and watch this thing. I'm just going to take my chances. And it shifted a little. It's not a big deal. Yeah, the A10's a good machine. I got to update my links down below in the description. I'm going to remove the Creality printers from there and from all my videos. The G-Tech A10 I did an unboxing on. I like it. It's a nice little machine. So, all right. So look at that. Look at that. Look how nice that looks. So these are all soldered and heat shrunk. And what we can do now is take this clip off and let the sleeving go back up. Just like that. So now these other two wires here, these black and yellow, or blue and yellow, these are going to be for our 5015 layer fan, which we'll install later. What I want to do now is get these wires routed for the other hot end. So what I'm going to do is I'm going to go grab my zip ties. I'm going to zip tie these to the existing cable going all the way down as far as I can. So just to make these all look nice and uniform. I had a bag of zip ties out yesterday. Here they are. I knew I had a baggie here somewhere. All right. So just to make sure these all look nice, and I'm gonna go ahead and start zip tying this all the way down, and trying to follow the, like, if you feel your cables kind of have a natural curve to them, so try to follow that. You know, I mean, like all this little stuff I'm doing, like all the extra screws, like that's why I tell people when they ask us about the dual kits, like, you know, it's not a just drop. It is a drop in terms of the board. The board installs in, like, you know, like you saw, a few minutes. But for the dual hot end, it's a lot more work. If we were doing the 2-in-1, it would have been as simple as then just mount the second motor, put the 2-in-1 adapter, and you're done. That's it. It's a very quick installation process. This is a little more work because you're running a second set of heater wires and thermistor wires. So just be mindful of that. The 2-in-1 is always easier than the dual. And you can still do a lot with a 2-in-1. You can do soluble supports with it, like PVA and PLA, or HIPS plus ABS if you got an enclosure, because PVA and PLA print at similar print temperatures. And as long as you purge out the nozzle, it doesn't matter that they're sharing a nozzle. But in this case, like this guy, if he wanted to do ABS in one and PL in the other, he can, because they're two completely separate nozzles. So, and there's a breakdown of the pros and cons on our website as to which one, like the benefits and negatives to each setup. So, and in my opinion, there's a lot more issues with the 2-in-1, or not the 2-in-1, but the dual hot end, because you got to make sure your nozzles are leveled. You got to calibrate your slicer. I'm gonna go through and just do all the basic testing on here, and I'm gonna make sure that each extruder is working fine on its own. And I do believe we have a profile on the site for the dual hot end. So I'll try to run a dual color print on here, but it's a process in itself. Once you get the hardware side done, it's a process in itself to get it upgraded. So almost done here with the zip ties. Just got like one or two more. And like I said, I just want to make sure this looks nice and the wires are not getting in the way of anything. So you can see here, they're all zip tied together, all uniform, all the way down. Jamming is usually related to not retracting fast enough or not having the retract sequence correct. And it really depends on your material too, because I've had some low quality PLAs that like maybe had moisture in them or something and they always jammed up. But if I used like rolls that were new and sealed, I never really had any issues with it. And ABS is pretty easy to do a 2-in-1 and not get jams, because ABS is typically more consistent than PLA, I've noticed. All right, so just to show you guys where we're at here. So we got, these are our new heater cartridge and thermistor wires here coming down. Here's our original plug. And then the extra wires that are coming out of our CR-10 box will go to these. So I'm going to put the quick connect connectors on here, and then these will be ready to connect up to the board. So I'm just going to snip these so they're all the same length. And we only got a few more things now. Since we're doing the dual Titan extruders, we do have our brackets here. So, and what most guys do is they'll print off these brackets here. So you got just a standard bracket. One will go here, and then the other will go on top. So they're kind of like sandwich. You stack them on top of each other. So they'll go like this with each extruder. So this just steps them out a little bit. So that's how we're going to mount those. Yeah, the Ender 3's bed is pretty bad. So, all right, I'm going to take this and dismount this. This, I think, is, I don't know if this is just a, I don't know if this is, what brand of extruder this is. Just some generic one he had. There should be one more screw underneath the lever on these. All right. Yep, one more screw, and it's a Phillips. I haven't messed with the FormBot Raptor. I don't really have an opinion on it. I believe that's a design that was stolen from G-Create, if I'm correct. So it's another Chinese clone. He's got some PLA shavings in there. Get rid of those. All right, so when you do the dual Titans, what people do is they'll take these and you'll put a bolt through, and it'll go through the top one and then into the bottom one. So if that makes sense. And make sure these all line up. These look good. And the thing is, we got to get a screw that's the same length, because we don't want to have them poking through on either side. We got to get a screw that's the same length as the distance here. So I'm looking at this. I'm probably gonna need to find my bin of screws, which is down here. What's that? I can say when I email them to get a new bed, they called me a liar, and that was it. Who's that? What are you talking about? All right. Just grabbing some M3 nuts because these use M3 screws. And I've got some small little screws here that should do the job. Let's see how far these stick through here. A little bit longer than that. And actually, these shouldn't really get in the way because these are the offset ones. So let me see here. Do a little test fit. So I haven't installed the dual Titan setup on any machines until now. I have seen a bunch of our customers doing it though. So this is what they recommended, is mounting them like this. Alright, so it looks like that screw length will work. We got enough to go through. Perfect. Alright. So what I need to do is find 3 more screws of these exact same length. People that make the Ender 3, yeah, you're not going to get any sort of response from them. Good luck. And I tell people, when you buy a Chinese printer, do not expect any support. It's just how it is, unfortunately. If you want support, go buy something like a Prusa, you know, or an Ultimaker or a Lulzbot. You're just not going to get any sort of support from a Chinese company. Like, period. I'm actually finding these exact screws I need pretty quick. Well, that's a trade-off. You know, you save money on the printer, but you're going to pay more later down the road. And if you're okay with that, and you're okay with not getting any support later down the road, then go with a Chinese printer. You can't have your cake and eat it too. You know, it's like why people give me a hard time about what we charge for like our bed leveling kits. Well, it's because we have to pay someone to do support, and that someone for a while was just me, and now we actually hired someone who's Mac in our chat just to do support full time, because we have so much of a demand for support that I have to pay a guy full time to do support. You know, that stuff doesn't come free, you know. Now here's a little trick I like. So on these have like a recess for the nuts. Now the nuts don't always fit in perfectly. I can probably take the pliers and push them in. Yeah, I can in this case. If for some reason you can't push the nuts into the recesses with the pliers, what you do is you can take your soldering iron and push the nut in and heat the nut up just enough so that it melts it into the that like recess cutout. And that's a really nice way to embed, you know, threading into your printed parts, is melt it in with a soldering iron. And I've been doing that for a while now. Just gotta make sure that these nuts are all M3s. They looked like it. This one just looked a little off. I want to make sure it was actually an M3 before I went ahead and put it all together and found out it wasn't. Alright, these are actually all going in without the soldering iron. It's very hit and miss, I've noticed. But I have melted them in the past, and it works great. I think the reason these are actually going in is because I have been playing with Linear Advance, and Linear Advance has been making my parts a lot more accurate once you actually get it dialed in. So the actual like holes and everything on these are in the tolerances they should be. Alright, so I'm just going to go ahead and screw these two together. That one's biting in. That one's biting in. Well, this one gonna go? It feels like it wants to. Let me see if this one will go. Yep, this one's going. Alright. Maybe this back one will go now that I've got the others started. Yep, there we go. Alright. So all our screws are going in. They're biting on. And we've got our Titan mounts here. All right, I'll make sure they're actually biting into the nuts here. All right, I can't tell. I might actually need to use slightly longer screws. So I think what I'm feeling is them biting in is them biting into the actual plastic. Let me see if this guy's got something slightly longer in his bin here. he has a lot of these flatheads that are slightly longer, so that's clutch. All right. So we will use these since he's got them here. So you only have like one of the size I need? Oh, maybe two? Two? We got two. Because they're in this other compartment with these other screws, and they're so close in size. I don't think his are sorted. Mine aren't either. So I can't really say anything about that. Let me see if these are slightly longer than mine. Those are not. These brackets are on Thingiverse. These are for the CR-10 Titan mount, and it's for the one that's slightly longer. There's one that puts it out farther from the extrusion. That's what these are. All right, that's biting into the screw now. All right, and just for documentation purposes, these are 9mm M3s. So if anyone's wondering what size screws I'm putting in here that actually fit, are 9mm M3 screws. I do actually have a couple in here that I took off the hot end for the fan. So the ones that come with the fan fit. They come with your stock CR-10 fan. What I'm looking for now is the bit, the 2.5, that I use to take the other screws out. It's a 2.0. Where's my 2.5? Okay. Yeah, so you'll need, these are M9s it looks like. 10s would probably work as well, M10s, M3x10s. It came out to like 9.2 when I measured it, so could use M10s. They would do the trick. Try to screw these other screws in, I realized they use a different bit, so I gotta take all the old ones out that were too short, which I believe these are M9 or M8s. So cost-wise, depends on what you do. If you do the cheaper extruders, which are the aluminum ones that we carry, that'll shave some cost off, because this guy went with the high-end ones we have, which are the tough extruders, which are the Titans, and the aluminum ones are $12 a piece. These are $39. So to give you an idea on cost on just extruders, there's a big difference. But in my opinion, the Titan ones are the way to go. They just offer more consistent extrusion, easier filament loading. You can print flex on them. So it's just a lot better in general. But if you're on a budget, then you can go with the aluminum extruders because they're a lot cheaper. All right, so we got our brackets on. These are not going anywhere. And what we're going to do is we're going to mount the extruders on here. And these do come with the screws to mount them to these printed parts. They do include a bracket. This is just a generic bracket. And you could drill holes into this and use this bracket. This is an injection molded bracket, but you'd have to modify this. This is just included with the kits we sell. And some people use them, some people don't. So we've got our two extruder motors. We got his original one here, which is a Creality, and we got ours, which is also Creality, but it looks like the sticker came off. But same exact motors. The motor does come with The motor does come with the kit. So if you, and it's the exact same motor Creality uses. They're direct from Creality. They're not like third party, if that matters to you. But they're all genuine Creality. So when you're putting the Titans together, there's a bunch of parts in here. It's pretty simple. I've done it a couple times, so I'll show you. So the first thing you're gonna do is take all your Allen wrenches out. I'm just gonna use the ones that are included, and you're gonna have this guy here. And you're going to want to take off this screw right here. Okay, so you're going to want to unscrew this screw here, and this will remove the lid. Okay, so you take the lid off, and you've got your gear here. Okay, and this is, so one benefit of ours versus the E3D, this comes with a hardened steel gear from the factory. There's no additional upcharge for this. E3D charges you additional for it. I believe it's like 15 or 20 bucks for this, just for the gear. Ours also includes the Bowden fittings, which is another upcharge E3D charges you. Ours includes it. So you're going to take the shortest screw out of the kit, which I believe is an M3x8, and you're going to put this in. This will secure this to the motor. So you're going to put this into the hole right here. You see there's a hole right there. You see my finger moving? This goes into the hole, and your filament exits where this groove mount is. So we're going to want to have this like this on here. So I'm going to take our motor, and I'm going to put this up in here. And then we're going to take the extruder body, and we're going to tighten down this one screw. Once I get in the hole, that would help. So you're going to tighten down this one screw, and this will secure the motor and this body to your mount. And you can see now it's going to stay. So what we want to do is we want to put our gear on then. I'll move this around so we can see. So what's going to go on here is you're going to have your feeder gear. And if you can see, there is a little grub screw on the feeder gear. And you want to be careful not to strip out the grub screw. You strip out the grub screw, you're not going to be able to tighten this down, and the extruder is going to be useless. So if you notice on the motor, there's a flat spot. You usually want the flat spot to align with the grub screw. So when you're putting it on, you put the grub screw towards the motor, not up here, because you don't want this part riding on the teeth of the gear. So you want to put it towards the bottom where it's not going to be riding on, and then press it onto your motor shaft. And if you're like me, you're going to want to back out the grub screw just a hair so it's not catching on the shaft. And then you'll be able to put it onto the actual motor here. If there is some resistance, it's fine. Just push it on, and it'll eventually slip. These tolerances on the motor shafts, or there's actually, I think there's stuff still stuck on his. Yeah, he's got like little grooves in his where the stock feeder gear was on. So that's what this is hanging up on. So if it doesn't go on right away, just take it off and put it back on and just play with it till it goes on. And once you get past the original grooves, this gear is going to go on pretty smooth. So usually if this doesn't go on by hand, I'll take the pliers and I'll push on it, hold the motor, and there you go. We're past the part where the original feeder gear was. So because it made an indent in the shaft, this was having a hard time getting past it. So just push it past, hold your motor, and you'll be in business. Now, what you want to make sure you do, well, is not drop all your screws, is take your feeder gear, and I like to put it in here, and you want to make sure that the feeder gear and the feeder gear and the gear on the shaft, the tops of them are flush. So I need to pull this out a little bit to get this to line up. You want to make sure they're both flush, and then make sure that grub screw is aligned on the flat spot of the motor. So you got to kind of get in here, and what I'll usually do is tighten it up. I'll hold it with my finger. I'll tighten it up, just kind of snug it. You'll start feeling it bite. So now when I put the gear on, it's still got enough tension to not move it. I'll check it, see if this needs to be moved, and it's perfectly flush now. So the top of this gear is flush with the top of this gear, and I'm going to go ahead and tighten down the grub screw further. And make sure you get the Allen wrench all the way in there, and then tighten it. If you don't have it all the way in, you'll skip it and then what's going to happen is you're going to strip out that grub screw. So take it easy, Tyler. Okay, so we put this in. If you notice, this can rock, okay? So what you want to do is rock this up to where this is all lining and these gears are meshing smoothly, okay? You want them to mesh nicely, because what will happen is if you don't have these meshing smoothly before you tighten everything down, what's going to happen is this gear is going to have play in it and you'll hear clicking while it's printing. So if you hear clicking when you put one of these on, it's not going to affect the print really. It's just going to be really annoying, and that means that there's something out of alignment. So the next step I like to do is I'll take there's a bunch of these little pieces in here. There's different adapters for 3mm and 1.75. We include all of them. I use the white one here because this has a little bit tighter hole on the PTFE. There's a black one that's labeled 1.75 on the bottom here, and it has a slightly bigger hole for if you're running slightly bigger PTFE tubing. Now, there are also two pneumatic fittings. This one's for 4mm or 3mm filament, and this one's for 1.75. So this is the one we're going to use. Now, if you have an older version, these, even though these don't look as nice as the flush mount ones, these hold on to your tubing a lot better. So these are the ones that we sell now, because these fittings are a lot better than the one that's kind of integrated into this piece. They grab onto the filament a lot better. So you're going to push this into the groove mount. Now, actually, before you do that, you're going to tighten up the screw here that you originally put in. So tighten that down, okay? And then make sure this is all still meshing nicely, okay? So put your finger on here, turn it. It should turn nice and smooth. We're getting nice and smooth movement. So put your groove mount adapter in and press it all the way in. And then you're going to put your filament guide and push it all the way in, okay? It's going to be a pretty tight fit. So this stuff has really tight tolerances because you don't want a ton of play in your stuff. Make sure this is flush. So run your finger over here. Make sure this white part is flush with the black part here. You might have to really push on it, okay? So then you're going to take, and yours might have one, yours might have two, depends on the version. There will be at least one type of thumb screw in. There's a metal one and the plastic one. They both do the exact same thing. It really depends on what our supplier was shipping. They seem to, I told them they only need to put one in, but for some reason they put two in. So since these have the nicer looking metal ones, I'm going to put the metal ones in. So you put the little, I believe it's M4, you put this little nut on here, and then the spring, the small spring goes on the end here. And then this goes right here. So you put that, the groove of the thumb wheel goes into the plastic groove, and you're going to want to hold this, and this spring will sit in the little nub on the arm here. So you're going to slide this onto your motor's arm, and then you want to get the spring over the nub and push it all together, okay? So we got this. Do not tension this until the cover is on, okay? So we got this on here, and now we're ready to put the cover on. So the cover goes on like this. Everything will line up nicely, and it snaps in. So out of all, you will have two sets of screws. There's slightly longer screws, and there's the normal length screws. And then the shortest screw is the one you took out when we started, which is this offset one. This one doesn't go actually into the motor. So we're going to put that one in, and we're going to tighten this up. And then I like to go and do the opposite corner. And tighten this up here. And these top two, well, top in this respect, these top two you can tighten down, okay? Don't crank them down. It is a plastic part, but you can tighten them down. The one you do not want to over tighten is the one here that has the actual bearings in it, because what will happen is it's going to put pressure on the bearings, and it's going to either cause it to not move entirely, or it's going to cause it to fail prematurely. So we got our last one in, and that goes through here. And again, tighten it down. Now, you do not want to fully tighten it. I would say once it starts touching the lid, give it like a quarter turn, maybe half, kind of feel it, and then move this gear. So this has got some resistance on it now. So I'm going to back this off a little bit, and now it's moving a lot smoother. Because if you over tighten this gear is not going to turn smooth, okay? If you're worried about this coming out, you can put some Loctite on the actual screw, but I haven't had any issues with these actually coming out. So you want to make sure it moves smoothly when you're done here. So I'm able to move this smoothly. And then we just repeat for the upper motor. So I'm going to put this in here. I don't think I can rotate this to the side because it's going to hit, yeah, it's going to hit the connector's going to hit the side of the bracket. So we're just going to go ahead and install the second one. Same exact way we did the first one. So we're not going to use the included bracket because we printed our own. Let's see, did they include the metal thumb screw in this one as well as the plastic? They sure did. So either one works. I had requested that they put the metal one in at one point, so I think my supplier just kept adding it on even though they don't need it. But whatever. It's only, I think it cost us like $1 more to add the metal one in. So some people like the plastic one, some people like the metal. I'd rather give them choice. Yeah, blue Loctite is the one that will come out easily. I believe the red Loctite is the one that you will probably not ever get out. So again, I'm putting in the one screw where the collar is, or the groove mount, if you want to call it. And tighten that down. And let's get our grub screw all lined up here. And I'm going to use the Allen wrench that came with this one, just in case that other one slightly stripped when we were putting everything on, because I don't want any chance of actually locking or stripping the grub screw. Because if you strip the grub screw, it's essentially useless until you can get a new grub screw. So see, this is a new motor. See how this one went right on? It's because it doesn't have any teeth mark from the grub screw of the prior gear. That's why it went on so smoothly. So I'm going to go ahead and line this up here. Please tell me this isn't going to hit this. I'm going to have to make a spacer to put between here. Actually, I have spacers. I'm going to have to put a spacer in between these because this gear is hitting, it's just ever so slightly hitting the tensioner here. So I'm going to take this top one off and put some spacers. I've got just ABS spacers printed already, luckily. So I'm just going to put a spacer in between here and that should fix it up. I'm surprised none of the other guys mentioned that to me, or in the Facebook groups, that they had to put a spacer in between. Luckily, I put the screws in from the top here. Otherwise, I'd have to completely take that other Titan apart, which would suck. The one in the bundle is for use with the aluminum extruders, not with the Titans. Oh, you said you need a spacer? Dang it, Tor. Why didn't you tell me that? I must have glossed over that on the Facebook post. All right, well, we'll need slightly longer screws. Oh, this is the joys. This is the beauty of seeing this live, is you get to see all the stuff I go through, all the trial and error. So I've got the spacers from the dual E bracket. I'm thinking I should only need one, I would say. So I'm just going to put a spacer here to space this out. I'm going to assume that that looks like it should be more than enough. Just trying to see a dry fit here. It's going. I want to say one would do it, but I'd almost rather just put one on either side and call it a day, so I know it's for sure spaced out the right amount. So just kind of like a sandwich. So logic says that if these screws, okay, so if I get screws that are slightly longer, yeah, so these are, I think, these are like 6.6. Okay, both of these. All right, so I'm gonna put one on top and one on bottom. Yeah, these are gonna be too short. These might, I don't know if these are gonna be too long. They'll be fine for the back because the backs can go through all the way. But I don't know if they're gonna work for the fronts, so we'll see. So, more of the story is, don't feel bad if stuff doesn't fit on the first try. Like, it happens to the best of us. There's a lot of, that's why I say pick up an M3 screw assortment. Because you'll basically be able to do what I did. Oh, like I need something slightly longer, and now I have it. It helps with the trial and error side of things. So I'm just putting the longer screws in the rear here because since these are offset, these screws can protrude behind the motor and not get in the way of anything. So I'm going to go ahead and put these through here, and I'm going to thread these into the ABS bracket or the ABS spacer. Yeah, so like this is, I'm glad I did this because now I can add more info to our documentation page. Because like I said, I did the 2 into 1 already, but I have not done dual Titans or the dual Hotend. So this kind of knocks out the other side of the upgrades. So the whole dual extruder boards was, it's basically been just facilitating getting you guys parts that you wouldn't otherwise be able to get. So that was the goal, was to get boards that are drop-in, so it's much less work, because if you didn't have a drop-in board, you'd be having to splice new ends on everything, you'd be having to make cutouts in your actual physical control box to actually get the boards to work. Like, there are aftermarket boards that will work, but they don't line up. Like, nothing lines up. The LCD won't work. Like, there's just a lot of other things that you would have to take into account when using an aftermarket board. So despite these little hiccups here, it's still a heck of a lot easier. And these screws are actually dead on. They're not even protruding, so I can go ahead and put 2 more in the front here to lock this and make this all solid. And these are M3x16s, if anybody cares. And all these parts are printed in ABS, so they're very, very sturdy. All right, yeah, that bit into the nut. Felt that grab. Yeah, you got to have a screw assortment. I I have, the problem is, so like some of the things like the dual E bracket, which most people go with the cheaper extruders on the dual. And I get it, because these are not cheap. So the dual E bracket bundle is what we put that together, because that's what most people seem to be going with. But I think I might even make a new Titan mount based on actually installing this myself now and knowing the little details like this. I could even make one that has these connected and like a channel that this slides onto. So just a couple things to think about. All right, so I'm going to put this back on there and go ahead and put this back on, and we should have enough clearance now. Oh yeah, we're good. We're more than good now. Look at that. All right, in the same process as before, we're going to go ahead and space out this gear here. And this gear is almost, having it almost all the way flush with the motor top seems to be the right alignment. So I'm just going to pull it out just a hair and get my Allen wrench into that grub screw and tighten it down. I mess around in Mesh Mixer, which is very clunky, but if I need something more intricate designed, I don't know if you guys have checked out the About Us page, but my brother Doug, he does all of our 3D design. And he does the any sort of designs we need made. So anything that needs to be remeshed, because I hacked it up in Mesh Mixer and it's terrible, he remeshes for us. Yeah, so of the why, what does that mean? Let's talk about, as a customer, none of the bags were labeled. Put a sticker on the bag for, well, I'll label the parts when we take new photos, because this was recently added in, because we had some customers that wanted to convert to 3. And so we added more stuff to the package, and I didn't take new pictures yet, but the black portion, the one with the black fitting, is the one you want to use. But the actual white and black parts are labeled. So, but I'll probably cut up this video here and make a little VOD, or whatever people call it when you take a slice of your stream or whatever. This one is for 3mm filament. I mean, it's kind of self-explanatory, because if you put this on, it's not going to fit. It's not even going to grab onto the tubing. So if you put 1.75, it's just going to fall through. So no, blue is not 1.75. The black one with the silver fitting is 1.75. The blue with the brass is 3. But like I said, if you tried to put this in, it's just going to fall out. So yeah. And as you can see, like, I put this together real fast. Once you've done it a couple times, these go together real quick. All right, put the screws in. I probably will still make a separate video. The thing is, I lack time right now. There are blue 1.75s, but not for mine. Not for this particular product. The black is the 1.75. So when you're tightening this down, one thing I do too, if you squeeze right here to keep this whole assembly from rotating while you're tightening everything down, that helps keep your gear aligned. So if you just put your finger there while you're tightening everything up, it helps keep it all aligned. So we use Windows for all of our stuff here. We don't use any Macs. I use Sony Vegas to do all the video editing. And we got their, I think, Pro 15, whatever the latest one is. We just got that too. I was using an old one, like 13 or something. I had like a license from it that I bought way back when I was, what videos? Oh, I was doing editing. I was editing videos for this like recycling company, and I needed to get video editor. So, now what I'm doing here, if you look in the little window here, you'll see this nut, and as you tighten, as you go clockwise, it's going to move the nut up. As you go counterclockwise, it's going to move the nut down. I usually set it in this window about halfway. So I'm going to go ahead and just set, and this is how you set your tension. So if you need more tension, you turn it counterclockwise. You need less tension, you turn it clockwise. So, but I usually set these about 50%, and then if it needs adjusting, you can just reach behind here and change it. And you got your lever here, so here's how you load your filament. You lift this up, okay, it releases pressure on the gear. You can feed your filament in. There are little PTFE tubes included with each one of these. Here's the other one. And the PTFE is just a guide tube. And all you do is you push this in, and it will take, I usually kind of turn as I'm pushing it in. And this is just, like I said, a guide tube. And if you kind of turn it and push, it goes in. So you got a nice little guide tube coming off here. All right, and that's all the way in now. So there we go. We got our guide tubes, and we've got our dual tough extruders on here. That looks mighty nice. So yeah, what do we got left to do? We got to put the ends on the second hot end thermistor and heater cartridge here. And then that's pretty much it, aside from the 5015 fan. That's all we got left to do. So I'm going to go ahead and get these ends put on here and make this look nice. Oh, Mac. I thought you meant, why don't you use a Mac to make the videos? Not have Mac, our guy Mac. Yeah, I have brought it up to him before. Yeah, these, if you got these, like, these cloth-covered wires, they take a few tries to actually get through to the insulation to strip them. Yeah, I was like, how is using a Mac going to help me? Having to learn a whole new software suite. That's why I just went and upgraded my Vegas license, because I was like, I already know how to use it, and it does what I need it to do. It's not the best out there by any means, but it works for what I need it to. And that's what matters. To me, anyways. So I'm not going to cover all the slicer stuff in this video. This is just, we're going to go through the basic testing, and because like I'm not going to have time to sit here and dial in all these settings, because it is time intensive. So I will give you guys a quick rundown, but there is dialing in that needs to be done after the fact to get your nozzles aligned, essentially. So that's a part of the dual hot end anyways. You don't have to do any of that with a 2-in-1, which is why the 2-in-1 is my favorite way to do it, because it's a heck of a lot less work. And if you don't need to do stuff like completely different materials in terms of temperatures, the 2-in-1 is the way to go in my opinion. It depends on your use case and what you want to do. So like I said, since I don't have the crimps, and I did get a nice pinch on the wire, I am just going to solder this just to get the connection perfect. Come on. Ugh, lead-free solder. Stuff's not very fun to use. It's taking to the actual connector, but I'm trying to get it on the wire and it's just not playing ball. There it goes. All right. It's all down into the actual connector here and onto the wire, so that's not going anywhere. Cooled down pretty quick. All right, so I'm going to repeat the same thing for the other side. Like I said, I'm just crimping this over in here. So just giving it a nice good squeeze, getting the other end in. You know, and like I said, these were connectors the customer supplied, so I'm using them. I actually like them, so I may have to pick up a nice little... I know Matt or Keith was saying that I guess these are outdated or something, but I mean, for the sake of this stuff, this works pretty dang good. Like, this is going to be more than enough connector and contact to carry the amperage that the Hotend requires, which I believe is typically 3 amps, 3 maybe 4. I can't remember. I got to do the math. But yeah, all right. So we got our nice little connectors on here, and as long as these are cooled down, we can go ahead and push them into the plug here, which this is the end that clips on. It's got the little clip part on there, so these are going to go into the back side. And you can kind of hear them click in, which is nice. You can hear the actual pins clip in to the connector. I didn't really hear it that much on that one, so I'm just going to stick my pliers in here. There we go. I was like, I thought I didn't hear it. So, but this is in there now. It's not going anywhere. Now for this side, we're going to splice in our other connector, which apparently decided to go AWOL on me at some point. And of course it's the female connector, so I can't just reach into my box and grab another one. I have to figure out where that connector went. Welcome to the disorganized life of Tim Hoagland. Okay, well, it's not anywhere that I can see currently. Oh, you know what? I thought I said I set them over here. No, that was the wires. I don't think I set the connectors over here. No. Dang it, Tim. I need those for my thermistor. Out there. Didn't fall into the screw bin. Alright, well, let's see if I can find another one. I'm sure it'll turn up like right after I finish soldering up the new one. Not sitting on it, so. Oh well. We shall find another one in our bag of despair that will make most of you probably cringe with. Like, this is just like where all the random stuff goes. All the random wires. Like, I've got heat shrink tubing in here. All the random stuff goes in here. I just know that if I'm looking for, like, wire connectors, they're in this bin. So, like I said, tons of male ones. I can't find any females. Pretty typical for this YouTube channel, though, so. All right, got another one. By the power, what? By the power supply fan? No, that's the actual cable on that fan. But I got another one. We're all good. The day is saved. I want to make this the same length as the other one so it all lines up nicely. I'm going to cut that, and I made that a little long, so this will all... There we go. Great new... What are you talking about? Great new shooter in Florida today? Like, oh, you know what? I think I heard about that. There was, it's some esports thing, right? Like Madden or something. I thought I heard about that. Which is just fucking terrible. I don't understand. Yeah. Yeah, I heard about that. I don't get it. I don't get why people do that, why they want to inflict harm on others. Like, come on. So disgusting. Alright, on a lighter note, we're almost done with all the wiring. We just have the 5015 fan. Probably would be easier to twist these off here. On a side note, though, I didn't even know there were Madden tournaments. I didn't realize that that game had tournaments. I had no idea. I've only ever like seen the Counter-Strike and the other esports, like I knew League of Legends had one and a few other games, but I didn't know Madden even had an esports division. Yeah, do yourself a favor and don't get lead-free solder, especially for your projects. This stuff is just terrible to work with. It's very difficult to work with. It likes to get very like stringy sometimes, which I'm not a fan of. Ah, come on. Heat shrink's not one to go over. Alright, there we go. Scott, I like an extra dose of lead cancer when I'm working on my electronics, okay? As if the Chinesium in these don't give us enough. Gotta have extra. Yeah, this is rosin core lead free that I'm using. I can't remember the brand. I got it on Amazon. It was really cheap. I think I paid $10 for a pound, so it could just be that it's junk. But I have another roll of real nice, like, or, you know, according to the specs and the reviews, I got some MG Chemicals lead free, and it solders just as poorly as this cheap stuff. So I just remember like talking to engineers and stuff that, you know, work with this kind of stuff on a daily basis, and they would even like switch out their coworkers' leaded solder for lead free just to screw with them, and then watch them get pissed off when things weren't soldering correctly because it's lead free. Now, for our kit assembly, this is just my dicking around soldering station setup for like doing one-off projects. I do have this nice little fan here with a carbon filter just for a basic filter, but behind us we've got a $850 Hako full-on fume extraction setup that our employees use. So we do have the good stuff. I just don't use it for these little projects because it's not exactly practical to lug that whole thing over here. I thought about, because it's got 2 duct inputs, I thought about running another duct over to here and have it on this desk. So, but I haven't gotten around to doing that. All right, so we got our second hot end, our second thermistor connection. That's all good to go. Let me do this. I'm going to, because my back is hurting right now, because I'm an old man. I don't know how long we've been streaming. How long have we been streaming for? 3 hours. Holy crap. Okay, so I'm going to sign off here. I'll be back in about 45 minutes to an hour, I want to say. Or how about this? It's 9:20. I'm going to stop the stream. I'm going to come back at 10 o'clock. Okay, so 10 o'clock my time, so that's 40 minutes. I'm going to get up, stretch, go have something to eat, and I'm going to come back, and then we're going to wrap this up. So check back here in about 40 minutes, 10 o'clock Central Time, and I'm going to be back. So I'll be back. I need to get up, walk around. I need to eat something because I really haven't eaten really anything all day. So I'll be back, and then we'll wrap this up. Thank you for stopping by, and I'll see you guys back on the stream in about 40 minutes. Dang it! All right, so can you guys hear me? No, I was saying Archer was being bad and messing with Samantha while she was trying to pack orders, so he's in here with me. You can see him. He's just like, oh my god, I'm being held. Yay. So anyways, we should be all good here. Let me send out my live tweet there. I forgot to do that earlier. So he's probably just gonna chill in my lap for most of this. I'll probably have to dump him off in a little bit, but I figured I'd give him some attention for a little bit here. Anyways, so I grabbed some of our tough tubing here because what we need to do now is route our hot end tubing to each extruder and decide which extruder we want to have be 1 and which one we want to be 2, or 0 and 1, however you want to refer to them. So I'm going to have, I think it makes the most logical sense to have the bottom one be the extruder 0, or the first one. So we're going to go ahead and I'm going to get an idea of how far we want to cut the length. So I'm going to put this into the first hot end here. And that's all the way into the heat break. And to get an idea, we just want to have like a little loop here. So we don't want to have too much and we don't want to have too little. So what I usually do is I'll test it and then I'll move it back and forth, make sure that I can go my max distance on each one before I cut the tubing. So we got a nice loop going here. I'm going to go ahead and cut this. And these are the little PTFE cutters we sell in the shop. They're really handy. You just put your tubing in there and that's simple. You get a nice clean cut. So if you pick up tubing from us, go ahead and grab one of those. Now, these are going to be about the same length, so I'm going to take this and use this as a template and cut one more length of tubing here. And I'm going to do it about the same size, but just a little bit longer since this has got to go up to the top here. And it's a little further over. So I'm just going to give it a hair bit longer and cut it. So, and this was like 2 meters. You can probably get away with using 1 for 2 hot ends. You don't need to buy 2 meters. So I'm going to put the longer one into the second hot end here. And you want to push it all the way in. You'll feel it go into the heat break. And then again, push it all the way in. So this tube is going to go all the way up to here in the extruder. So you're going to push it in and you'll feel it. It kind of catches a tiny bit on here, but then you feel it slide all the way in. And notice how we're maintaining a nice loop here throughout this whole process. You want to have a nice loop and use the natural curve of the tubing to your benefit. Whoop. And again, push it in, you'll feel it touch, and then that's it. And then just make sure you got good movement here, which we do. I may actually, looking at how these tubes are routed, maybe I'll put this in the top one. As long as my customer knows which one is which. Let me see here. Let me see if I like how that routes a little better here. So I'll make sure this goes in all the way. There we go. Yeah, I'm going to put that, so the top one's going to be extruder 1. The tube just like flows better if you see here. Like that looks a lot nicer than the other way I had it. What's the difference between this and the Capricorn? This is only $8 a meter instead of like, I think they charge 12 for Capricorn on average. I know I paid 12, almost 13 a meter when I bought Capricorn when it first came out. And this actually has discounts if you order 2 or more. I think it's a 13% discount or something like that. It's at least 10%. But this stuff we've actually sent it to a lab to be verified. Its melting point is 327C. And apparently Archer sees a bug. Oh, there's a bug on my wall, which is why he's freaking out right now. So it's just an alternative. It's high temp. It's got, now none of this is in the melt zone, but the reason I like using this is because it's got the 1.9 millimeter internal diameter. So that means there's less slop inside this tubing. And when you actually do a retract, it's actually retracting the filament instead of just taking up the slack in the tubing. That's why I prefer this stuff. And it is a little slicker than your standard PTFE because it's just a better quality PTFE tubing. So those are my thoughts on it. You know, your mileage may vary. I really like it. That's why we sell it. So what I'm going to do now is I'm going to route the wiring with all the tubing. So I like to just take some zip ties and just loosely zip tie my hot end wires to my PTFE tubes. So, and I personally won't use Capricorn because they actually attacked our company like behind the scenes, like literally sent out a letter to other companies saying a lot of bad stuff about us. It's actually on our website. I posted an article making a comment on it, but they basically attacked us just because we had a competing product, which is completely insane. So I literally ripped all their tubing off my printers. I will not recommend their stuff anymore just because of the personal attacks that we had lodged against us. So Tim will never buy Capricorn again. So it was completely uncalled for. It's like, come on guys, like we're just offering an alternative here. Like I never even branded it as a Capricorn competitor on our site. Like they just got super pissed off that someone else was coming into the space that had a comparable product, and instead of just being more competitive, they decided to slander us. So it sucked. It really sucked. So, and it sucks because this is such a tight-knit community. It's like, how did they not assume it wouldn't have gotten back to us at some point? You know, like we know a lot of people in the 3D printing industry. You know, and someone, you know, sooner or later was bound to send us the info that, hey, these guys are literally slandering your company over selling a competing product. You know, and I was very careful not to even list it like in our keywords on the product, like not even list it at, like not even have like Capricorn or any of their other product lines mentioned in there, you know, because that's what some people do. They'll put keywords for competitors in their product listing and the meta tags and everything, so it shows up when you search, which is great for marketing. But I didn't want to broach on that, and we still got attacked. So I don't know. I'm just trying to run a business here and help people out and put food on our table and have fun with these machines, and we're over here getting attacked by companies that can't hang apparently. So anyways, I zip tied these just loosely. So now we got everything following the one path here. And I am going to put the ABL sensor on here, but I'm going to tape that wire to these because I want it to all be, I like having everything separate, okay? So like if I needed to take the PTFE tubing off, I can clip the 3 zip ties for the PTFE and I only have to mess with those versus bundling everything as one and all your wires go, you know, when you take the zip ties off. So that's my methodology. You can do whatever works for you. You know, I do these streams so you guys can kind of see, like, especially when I'm doing custom work like this, what goes into it. I mean, you guys saw, like, you know, I had a part that didn't fit, and no big deal. I just, you know, luckily I had ABS spacers printed that we sell with another product, so I've got these spacers laying around, and, you know, I made it work. So, you know, yeah. Yeah, Scott, ping me later tonight once I'm done with this, because I plan on putting out a video following up on this, because I'm just kind of at my wit's end with these companies that are not playing ball, and I do want to give props to the companies that didn't play ball. And I also have some information I need to share with you too that's kind of on behind the scenes that I have, so you'll enjoy it. But anyways, I mean, we're pretty close to done. The only thing I have left to do on here is I need to mount our EasyABL. I need to mount our EasyABL sensor here and do its cable management. And then I also need to mount the 5015 fan. So I already got the wires here, so it's just as simple as me splicing in the wires. And I think I'm going to put our 5015 on instead of, he's got some really cheap ones and they're not going to last more than 2 months. They're the same brand I bought from Amazon before we started selling fans, and mine lasted about 2.5 months and then it died. The bearings were grinding. I added oil to the bearing. It made it work for a couple more weeks, but then it just completely died. So, you know, I tell people, it's like, so our 5015 fans for one is $10 for the 12 volt, and the 24s are $16. But I can guarantee you that they will outlast any of these cheap fans you can get for like $5 or $6, or, you know, 2 for $10 on Amazon. Like, buy it once, get something good. Like, I don't sell low cost crap. You know, like, it's like with these you know, Titan clones we sell. Like, these are some of the best clones on the market. They actually follow the E3D guidelines in their actual designs. You can take parts off this and put it on E3D and vice versa. It's exact. You know, so there are certain things we carry that I pay more for that I could pay less for, but you guys would get way less quality. So I want you guys to know that when I sell something, it's because I use it. I have these on almost every single machine here. I have the tubing on all our Bowden systems. I use the same hot ends I sell. You know, I'm not over here selling you guys clones and using, you know, E3D stuff or whoever. You know, it's, you know, I'm using our kits. I use all the same stuff that we sell in the shop because it works and it's good quality stuff. So, you know, I also don't want to be dealing with a bunch of returns. So if it means I got to charge a little more and get a little more quality, I'm going to do that and let people, you know, see that we do have good quality stuff. You know, because I can tell you that buying random hot ends off of, you know, random hot ends off AliExpress for $4 or $5, they're going to be terrible. I've done that. I've been through that song and dance, and it's not worth your time. By the time you get it, you fight with the seller to get, you know, refunded or get a new part, and you're waiting a month. It's not worth it. Like, you know, it's just buy it once and buy it right the first time. You know, if you really want top quality, if you really care about everything being absolutely perfect in terms of like machining quality, and I'm not saying the stuff we sell is bad machining quality, I'm saying E3D is a little more polished to their machine parts, you know, but it's not anything that affects the performance of the item, you know. So we check all our tolerances on the hot ends as they come in. You know, we'll pull random ones out, completely test everything, and if we see anything off, we pull the entire stock and test everything, you know. And we also have the suppliers doing QC. We pay them extra to do QC that they normally wouldn't do if they were selling to anybody else. It costs us more, but again, I would rather have more quality control than have more issues for our customers down the line. You know, it's that simple. So, all right, let me flip this around here. We got our extruders mounted. We got all our cabling done for the second extruder. So, what's up, Roush? So, this is coming together quite nicely. I don't know if you guys, how well you guys can see that. There you go. So this is a pretty nice looking setup already. Like, this is very sharp. So we got our second hot end, or I believe this is our first. Actually, I gotta look this up because I'm pretty sure this is the first hot end. And either way, we can switch it back here. I gotta look it up. It's been a while since I looked at it. I did all the firmware programming, and I'm just like, which one's technically supposed to be the first and which one's supposed to be the second. And I believe you can also change it by just adjusting the offsets too, which would, so like if for some reason this one's number 2, if I change the offset, it'll compensate. So, or I can always just flip the wires in the control box. Either way, I'll get it figured out. It's been a little while since I did a dual hot end instead of the 2-into-1. So, anyways, this is the bracket for our ABL here. This gets screwed on. There's one screw that goes here, and then that will hold the ABL sensor in place. I just want to make sure that screw hole is lining up. Looks like it is. I think this only goes on, yeah, this only goes on one way. I was like looking at this, I don't think it'll go the other way. So I just need to get a screw in there. Might help if I had the right size bit on the drill, or the the screwdriver here. Man, this got messy real quick here. Just a lot going on in this general area. Okay, he actually does have a screwdriver cut out to actually get to the Petzfing bolt. So that's good. On one of the older versions, he didn't have that, and it was kind of a pain to get to that bolt. I'm trying to find my 2.5 driver here. Got my 1.0. Oh, here we go. Okay, I thought I'd been putting them in here. I was like, I thought I'd been putting the parts back in. See, and that's what I like about the Petzfing stuff. Like, the fit and finish on this stuff, like, he's done a lot of work to make sure all this stuff actually fits together nice. Like, I appreciate David and everything he's done. So that's going to kind of get in the way. I got to move this up just a little. And then, because I need to be able to get my screwdriver right here, because there's going to be a screw here to hold the duct on. Alright, lead screws are feeling nice and smooth, so that's good. I don't think he was having any ABL issues. I think he was just having hot end issues, which this is obviously going to resolve since we're completely changing the hot ends. Alright, so what I'm going to do now is I'm gonna hook this up, and we're going to heat the nozzles and get them up to temp so we can tighten them and do a hot tighten on them. So let me get these up more. All right, we'll give you guys a nice shot of the nozzles there. All right, adjust the focus a little here. Oh, a little too far. There we go. All right. And yes, I am trusting my soldering job. All right, I'm gonna plug this into one of my strips here. Luckily, none of our machines are running right now because it's Sunday and I typically take the day off. All right, so where's our new? So we got our new harness here, and look how nice that links up. Look at that. So this is like the perfect length. There's not too much, there's not too little. I got the perfect amount going to the extenders and quick connects I put on here. Alright, that one's seated up nice. So to that one. The nice thing is I can always adjust the, it's slightly a little too long, but I can just put the extra back into the control box. And there we go. And then I'll zip tie it all nice when we're all done here. So I'm gonna hook up the bed. And the other stuff we don't need to hook up because we're just testing heaters at this point. And this power cord is just barely long enough. All right. That fan sounds terrible. So I want to show you guys this. So when you get the board from us, come on, it has a testing firmware. So when you turn this on, and what the testing firmware is just a stripped down version that gives me I/O pin statuses. And if it fails, it'll display something in the serial. So this is just a testing firmware, so you're going to need to update your firmware. But everything's looking good. You can see our hot ends are both showing. So I'm going to heat one of the hot ends. I'm going to go here, go to prepare. Actually, I'm not going to go to prepare. I'm going to go to control, temperature, nozzle 1, and I'm going to set nozzle 1 to 100°C. Just to see what goes on here. Okay, nozzle 1's at 100. It's heating up right now. Okay. And so nozzle 1 should be, if memory serves correct, nozzle 1 should be the left one, which is only at 55. Yeah, it's definitely the left one. Okay, which is what I thought. So we're looking good on nozzle 1. It did overshoot a little, but we can PID tune that. So what I'm going to do here is I'm going to set the temperature to 260 on both of them. And these are all metal, so these can take it. So I'm going to do 260 on the left. And let's see if the right heats up nicely. All right. They're both heating. Both heating up, so that's good. Good news for us. It smells like Chinesium. That fresh black smell. Now, the nozzles look pretty level from here. And you will see sometimes, I haven't seen it yet, but you will sometimes see like little smoke whiffs coming off. And that's just like the machine oils and stuff burning off if there were any on there. I'm just going to feel these connectors here. These aren't even getting warm. All right, well, left one's at 260 already. The right one's not. Now, I'm going to grab a set of pliers, because usually what I do is I grab the block with a set of pliers, and then I use a wrench to just snug it. So you can see here, we're heating up. Yeah, I got to PID tune that hot end real bad, because it's nowhere close to the stock one. All right, so I believe a 7 mil is what we want here. Did my guys put the pliers back? Doesn't look like it. Which means they are lost in the abyss somewhere. Should have grabbed those on break. I know I have a set in here. I have a couple sets actually. I got some nice needle nose, but I don't have my large ones. I don't know if these will go on the block or not. Is it gonna be large enough? Oh, there. Okay, I can use these. All right. So basically, I'm going to try to get the camera in here while I do this. So basically what you want to do, and you might trigger a thermal runaway. So you've got your heater and your thermistor wires, okay, on either side. Make sure you do not get them with the pliers, okay, because you will screw stuff up. So you're going to grab it, and you're just going to tighten the nozzle against the heat break. Just snug it, okay? We're not talking about cranking it down. Just give it a little snug, and that's it. That's all you got to do. And I'm surprised this hasn't I'm surprised this didn't trigger a thermal runaway, because it dropped like 10 C, but it recovered real quick. So I'm going to do the same for the left side here. Go in, grab the block, take your socket, give it just a twist, and that's it. That's how you tighten your stuff down, okay? So I'm going to let these heat up. I'm going to let these sit there and idle for a little bit and just make sure that they don't loosen up. Now, in terms of leveling the nozzles, like I said, these are really good quality, like, hot ends. These are based off of the E3D Chimera design, and these are dead nuts. Like, these are really, really level already. So, but I think our X carriage actually has a tilt to it now that I'm looking at it. And I don't know if that's because of these, if one of these wheels is off or not. It looks like it might be. Let me loosen this up. Is this a 7mm nut? No, it's not. It's an 8. All right. I was like, where's my socket set? Yep, it's 8. All right. So what I'm going to do is make sure that this, without touching the heater blocks, make sure that this is tightened down here. Because this is sitting crooked, this whole assembly here. I know I had a wrench for the here it is, for the eccentric nuts here. Make sure that when you pull on this, it doesn't wobble. So that looks better. It's less crooked. It's almost completely flat too. Could also be that the gantry is a little off too. That's throwing me off. But yeah, that looks good. So we got both our hot ends. They're within a degree. They'll be dead on once I run a PID tune. But they're like between 260, 261, and then you run a PID tune and everything will run nice. So both nozzles are heating here. And like I said, if you do a PID tune, come on. If you do a PID tune, they'll be a lot more stable, because what happens is it overshoots and undershoots because it doesn't have the PID values. Now you can actually PID tune right from the menu. And I want to say this will do both nozzles. I haven't tried with the dual. I haven't tried the PID auto tune with the dual, to be completely honest. But I believe it'll apply the PID settings to both hot ends, not independent. And this is still the testing firmware. So this we're not going to actually print with. We still got to connect this to our computer and print with and update the firmware. So this is just a testing first. So you can see the nozzles dropping. It's doing a PID tune on nozzle 1, it looks like, because nozzle 2 is dropping. And then what it's going to do is going to ramp up, see how long it takes us to ramp down, and then it'll get the values and apply them. So it'll be more stable temps. So all I have left to do is mount the sensor in here. So put our ABL sensor in the bracket here, and then we put this guy on, which is our fan duct. And then I'm also going to put silicone socks on there. But you can see why I don't recommend printing this in PLA, is because of how close this sits to the nozzles. Like this sits very close to your nozzle. And if you have PLA, it will sag. It sagged on me. So, but these go on like this. You put a couple bolts in, and then you've got a duct for each of your nozzles. It's a very nice setup. This is the PETS fan for the Chimera Cyclops setup. And this uses your 40mm fan. We did not use the included fan that came with the dual hot end. Yeah, the gap's not much at all. So I believe it's 18 when I took a measurement last time. Yeah, pretty close. There you go. So they're 18mm apart. So not much at all. Now, the drawbacks of running the dual hot end versus, I'm going to switch back to my main camera here. So this is doing its auto tune. The main drawbacks of running the dual versus the 2-in-1 is, so now you have 18mm on the X and on either side that you can't print on because of the dual nozzles. So you're losing 18mm on the left and right. So 36mm out of this 300 he now can't print on. And that's just how it is with the dual nozzles. That's one of the drawbacks of them. But the benefit is you can run two completely different temperatures on your blocks. You can run two different size nozzles on your blocks. So if I want to have one with a 0.4 and the other one with a 0.8, I can have two different size nozzles on the same thing, and I can run two different materials through it that are completely different temperatures. So this board or this hot end setup, because this is all metal, will handle up to 290 degrees Celsius out of the box. We include not only the all metal steel heat breaks, but we also include what's called a PTFE pass-through. So if you want to use a tough tube, because some people have issues printing with an all metal, meaning they'll get jamming on PLA, which is very common for all metals. You can fix that by lowering your retraction and even adding a filament oiler that uses like canola oil. But if people don't want to deal with that and they just want to get the easiest use possible, you can use what's called a pass-through, which the heat break has a diameter hole large enough where you can pass this tough tube, which is rated for up to continuous use up to 275C, without it breaking down. You can run that in your melt zone. So you get the same ease of use as a PTFE line hot end, but with a higher temperature resistance. So now you can go up to like 290 on this stuff, but PTFE in general, no matter how good it is, may start to break down at that and even cause what's called off-gassing. So off-gassing is, as it breaks down, it can release harmful fumes that don't usually affect humans, but if you have like birds, if you have a pet bird in the house, they're not good at all for the birds, and even other small animals. So I always run all metal in mine, despite having to use a PLA oiler every now and then. I use all metal just because I prefer to have the all metal and not have to worry about the PTFE tube ever breaking down no matter what I'm printing at, or have any risk of off-gassing. So yeah, so we got the hot end together. It did its PID tune, I believe. Let me go control temperature, and it should have different values. Yeah, it's got completely different values now than what it had when we started. So I'll have to write those down because it's going to reset them when I update the firmware. So at this point, what I would do is I'm going to hook up the 5015 fan to these leads. I'm going to take my multimeter and see which one of these is positive and which one's negative, because this blue and yellow does not match up inside the control box. So I want to make sure the polarity is correct before I hook a fan up to it and smoke it. So I'll be enabling the Titan extruder option in the firmware because we're running the dual Titans on here. I will not be enabling the V6 hot end option because we're using our thermistors. Our thermistors do not use the same thermistors as a V6. They're a different type. So if you enable the V6 option, it's not going to get as correct of a temp reading. It will work, but the temps are going to be slightly off. I got to fix the guy's fan. I'm going to email him and see if he wants me to just replace the fan with another crappy fan that he has, or if he wants to put in one of our nice suit-on fans, or if he just wants to replace the power supply entirely with a nice Meanwell. I'll give him a couple options there. So, but this fan is not pushing much air. It stopped making noise, but it's not pushing much air at all. So I'm trying to think really more what I can show you guys. You know, basically for the sensor, it's the same Same procedure. I will have to put a custom offset on it because this is using the PETS Fang for the Chimera, which is not supported out of the box, but the offsets are on the PETS Fang Chimera site. So I just have to put those in the firmware. That's really all there is to it. So yeah, same thing. We put our sensor in, and he's got the Easy Connect here, but he actually put a cable coming out of his box for the power, so he kind of made his own hybrid direct wire type setup. And I'm just eyeballing this here because I've done it a million times. And then securing the sensor here. So because this is the testing firmware and this has E-steps and stepper direction for the stock extruders, I'm not actually going to be able to push plastic out of this until I update the firmware on here. But he does have these. These are kind of nice. I didn't know where he got these from. They're 3D printed. But these are like little cable clips to clip this to what looks to be the PTFE tube, which is kind of nice. So I can just kind of loop that around and snap that on. That's pretty nice. I like that. So, but you want to have a nice little loop for your sensor wire so you don't put too much strain on it. But these little clips are nice. I'm not even going to have to use electrical tape to put this on. This just clips right onto the PTFE. That's very sharp. So I'm sure it's probably on Thingiverse. But yeah, so if you guys want to ask me questions, I'm going to finish this up off camera because there's just too much stuff already on here. But this is basically what it's going to look like. We'll have a 50-15 fan in these two holes here. And then it's going to just push the air down to each of the nozzles. And I'm going to put our V6 silicone socks on these as well. So, and usually what I'll do after I run, like especially a new hot end setup like this, like the V6 style blocks or the Volcanoes, what I'll do is after I run it, check and look on the top of the heater block and make sure you're not getting any leaking. If you are getting leaking, shut the print down, heat them back up to 260C and snug them up again. It might take 1 or 2 tries to actually get a good seal. And this is applicable to our hot ends we sell and even the genuine E3Ds. I've built a lot of genuine E3Ds and they like to leak too. So sometimes you have to seal it multiple times. But it's a really simple process. You know, if you got the sock on there, take the sock off, clean off your block. Wire brushes are great for getting filament off your block, and then heat it up to 260C and tighten it down again. You can also go up to 270C if you want to. I've done that sometimes when I just get a block that just doesn't seem to want to seal. I found going up to a higher temperature like 270, 275 will usually do the trick. But other than that, like I said, I gotta basically put the fan on, bolt this duct on here, and then just go through the unified firmware for the rest of the setup. And that's about it. Like the whole complexity part of doing the dual hot end is running the second set of wires, and I did it real nice. You know, like I said, I used the wires that came with the hot end kit, so I didn't have additional wires. I just took the extra wire off of the hot end 1 because we're splicing into the existing cable for hot end 1. So we use that extra cable to make a little extension to come out of the box for the thermistor. And then since I didn't realize this, since the hot end does come with its fan, it's got a little 2-pin JST on here. You can cut this and use this for your thermistor wire to go to the board. So you can, if you're using the PETS Fang, which I think pretty much everybody that has this setup is using PETS Fang, you're not going to use this fan. So you can take this, cut this off, and boom, you have a 2-pin JST to use for your thermistor, for your second thermistor. So feel free to do that because you're not going to need this included fan on a CR-10 with this particular mount. So completely forgot about that. I could have used this little cable here instead. And I'm probably actually going to grab this because I took this from a MOSFET that I now don't have a cable for. So what I'm saying is just take it, snip the wire, and boom, you now have a wire to use for your second thermistor, because the second thermistor plug on the board uses a 2-pin JST. That's exactly what this is. So you just got to be resourceful. You know, like I'm always looking for, you know, thinking outside the box and looking for things, you know, like when the Titan didn't mount, I'm like, okay, well, I can just put a spacer in between it. You know, this is really custom work that we're doing here. There's really no other way to sugarcoat it. It's custom work, and if you're going to embark on this project, do expect to have to, you know, have parts to print. So try, if you only have one printer, try to pre-print whatever you think you might need. You know, luckily we have a ton of printers, so I never am in a situation where I can't print a part. You know, and if you're ever in a predicament where, you know, your printer's down, whether you do an upgrade or just broke and you need a part printed, you can contact us. We do custom prints. So if you just be like, hey, I need, you know, one of these STL files printed, two of these, you can send us an email with that and we can give you a quote, and we're pretty damn cheap, especially compared to like any of like 3D hubs or Shapeways. We're very cheap, especially even on ABS prints. So let me check the chat here. How did you get both nozzles level to the bed? I just put everything together and made sure mechanically, and I'm gonna bring this down to the bed and let's see how well this is, because you also got to take into account that your gantry has to be spot on as well, because if your gantry is off, then it's going to throw off your nozzle level. But here's the thing, these are machined really well, so they should be pretty damn close with everything together. Yeah, both are hitting the bed. Yeah. So I'm not going to have to do anything in terms of leveling these. They're both hitting the bed at the same time. So, because just like I said, just mechanically speaking, if everything's assembled correctly and the mount's on their level and everything's tight, this should be level when you bring it down. You can, like I said, depending on what version you have. So the PETS thing, there is a version where if you have the first run of the dual Hotends we had, the adjustment to level the heat breaks was on the back. And he actually came up with a mount that flips the heat sink so the back faces your fan. So you take the fan off and level it. E3D, when you're assembling, like per the E3D instructions, when you're assembling the Chimera or Cyclops, it should be level before you put it on here. And like I said, it looked level when I put it in. And here's the thing, if your heat breaks are the same length, your nozzles are the same length, and the holes that the heat breaks are going into are the same length, there's no reason it shouldn't be level. So I do have to say that with a dual setup like this, having your gantry level is absolutely critical. Like it was anyways, especially if you have ABL. But you have to have this gantry level, because if it's not, your nozzles are going to be tilted and they're going to be off level. So you want to make sure that your gantry is level and you're checking this. There's leveling box that you can print out to put underneath that to help. But you know, there's just certain things you have to make sure are correct on the machine. So like I said, I'm going to heat this up a couple more times, run through a couple cycles, and make sure the nozzles don't loosen up. And like I said, if they do, I'll just reheat them up, torque them down. And you want to just check that, because having it leak out of there is not fun. So I really like these clips this guy put on these sensor cables. So, but I'm going to get all this set up, get this hooked up, and I think maybe I'll jump on stream tomorrow once this is all set up and running. But I covered all the basics here: swapping the board, mounting your extruders. If you have the aluminum extruders, you can use the dual E bracket we have, and the other one just hangs off the back. On the Titan, you're going to need the spacers. Like Tor said, you got to space them 6 millimeters apart. And I'm looking to actually make a new model of this that'll make this a little more cleaner and have the spacers integrated, just have like a thicker base. And I used M3x16 screws to screw these two together. So, but that covers all the basics. Our hot ends are heating, they're reading the temps. We'd have to flash the firmware, and you can just follow the unified firmware guide for that. It's literally as simple as you got dual hot ends, uncomment the dual hot end option. You've got Titan extruders, uncomment the Titan extruder option. So it's very simple still. Even with all this, we've taken the time to get the firmware done. And the next release is actually going to support different extruders on each axis. So you'll be able to say, oh, well, I have a stock extruder on one, I've got the Titan on the other. You'll be able to specify that. Me personally, I always run matching extruders. It just makes life easier. especially when you're trying to remember your firmware setup and, okay, is it on E1 or E0? You know, what are the steps for extruder 1 and what are the steps for extruder 2? I just run the same one so I don't have to think about it. You know, and then I get the same quality of extrusion on both versus, okay, I've got the basic one on extruder 1 and I got the really good one, the Titan, on extruder 2. Well, the one with the Titan's going to print better and have less issues because the Titan's a lot better extruder than the stock aluminum ones. So, you know, that's just my 2 cents on that. If you guys have any other questions, now's the time to ask, because I'm going to wrap this up. I'm going to get this cleaned up here. I'm going to finish the 5015 fan and then update the firmware. And I'm going to play around and do some test prints on this. I'm going to ask the guy if he needs it back right away, because if he doesn't, then I'm going to keep it for a couple days and run it through its paces and try to further refine the profile we have on our site for the dual nozzles. Like playing with the, what's the word I'm looking for? The ooze shield, playing with the pride pillars. You know, just trying to get things more refined for everybody. So, but I might also put one of these on ours, because for testing the dual hot ends, I actually sent these out to a couple of our employees and friends because I have no use for a dual hot end. So I sent them out to them to get their feedback on it before we started selling them, and they came back positive, so we're selling them now. I really like them. The machining quality on them is great. The fit and finish is great. I'm very happy with these hot ends. So, and especially putting this together, it wasn't too bad. It's just, you got to take your time and do it right. You know, I took the time here, especially since this is a customer system, make everything look nice, organized, solder, heat shrink, everything. Do it right the first time so you don't have to worry about it later down the road. Like, I'm not going to be worried at all that these connections are going to have issues because they're soldered and they're heat shrunk. It's going to take a lot to make them fail. So, yeah, I know Roush, if you look him up on Twitter, he's been playing around with dialing it in. Dialing in his S3D profile, has been getting some really good prints out of them. So you can get it. You know, like I said, we're just facilitating the parts here. I figured I'd do the stream so you guys can see, you know, get an idea what's involved if you're going to go buy these parts, so you're not going in completely blind. You know, like I said, as much as I'd like to be like, oh yes, you know, support's bundled 100% with it, we can't afford to do that right now. And if we bundled the support into the price, we'd be charging so much because, you know, there's a lot of work here. It's just a lot of little stuff. But take your time, do it right. Hopefully this video is going to be helpful for people that are watching later on, so they can go back and get some tips. But you can see this came together real nice. It's a, you know, I'm going to switch back over here. Like it's a really sharp looking setup, you know, in my opinion. If might help if I had the camera focus. I turn autofocus off on these because it doesn't always work. But it's a very sharp looking setup, and that's you know, the duct isn't even installed yet. So I just think the contrast, like the blue looks really nice. Like, we're just talking aesthetics wise, I think the blue looks really nice with all the black ABS parts we printed and just all the metal parts. It just came together real nice, and I think the customer's going to be really happy with it. I don't know if he's watching. I sent him a link to the stream, but I'm really happy with how this came together. So